Okay, Prof. Asif, Dr. Musallam, you are online now.
Yes,
Okay, now
Good
start.
afternoon, everybody.
yes, Bismillah.
Yes, please.
So,
1 minute because maybe he is connecting his.
Prof. Muhammad, shall we start?
Yes,
Assalamu alaikum.
please.
Alaikum
Please
salam.
start.
So, hello everyone. First of all, in this good
Hello,
afternoon,
sir.
I would like to begin the symposium with a verse from the Holy Quran. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. صدق الله العظيم. I am your host, Dr. Musallam Tabuk, from Department of Mathematics and Science in Dhofar University. First of all, I want to invite Prof. Dr. Muhammad Asif Jondal. He is one of the best researchers in our Dhofar University. So please, Prof. Muhammad, you can start.
Okay, thank you very much, honorable speakers, respected participant, and all of my dear colleagues. On behalf of Dean Dr. Khalid, we would like to welcome you all here today in this symposium on research methodology, and wish you to thank you all for your support. This is a special day for us here at the Dhofar University. We are proud to hold this symposium. You know, research is an integral part of any institution and nation in general. Research activities influence the quality of teaching and the academic atmosphere in the institution. Today's symposium has a distinguished list of speakers from within and outside the Dhofar University. So also the audience, a few words to those who may not familiar with the Dhofar University. Our university has a dedicated department of research overseeing the various programs to encourage research. These include the incentive for publication, grants for attending conferences, and seed grants for initiating research. I would like to note that recently the Dhofar University achieved the Dhofar University ranked first in International Faculty Indicator in the Arab region and classified among the best 121 Arab universities out of 3,600 competitors for the year 2021 by the QS World University Rankings Arab Region 2021. Today's symposium is another step to strengthening the ongoing research activities in the university. Obviously, it goes without saying that great efforts went in preparing for this day because the preparation could not happen overnight. Just before we get started, I would like to express my gratitude to all of you so generously helped us make this event come together smoothly, especially Dr. Khalid, Dean, Dr. Vijay, Assistant Dean, Dr. Subi. Actually, he helped us a lot in organizing this online symposium and preparing your certificates. Dr. Saber for conducting this all event, conducting all the speakers. So thank you all for doing this wonderful job. We could not have done it without you. I ensure the symposium will be profitable and the next few hours will be enjoyable and fruitful for every one of you. Friends, this is all from my side. Thank you all for being a patient listener. I will see you in our coming symposium and conferences. Till then, enjoy that day. Thank you. Yes, Dr. Musallam.
Musallam, your voice is not clear. Check. Hmm?
Yes, now. Thanks,
Now
Prof.
we can hear you.
With a nice introduction. So we start today in this a good afternoon. We have a special chance because we have a very unique type of topics that are essential and fundamental to research methodology. We have 7 speakers today, so I hope enjoy your time. The only thing I want to mention is that there will no questions during the discussion because we have only 20 to 20 minutes for each speaker. So please write your questions in chat. I will allow some time in the end of the symposium to ask questions and discussion. Now, let me to start with Prof. M.A. Faruqi. He has his PhD and is the former principal of Rizvi College. And here I want to mention about Rizvi College. It's one of the famous college in Pompeii in science and arts. He has a very good practical research now associated with a different organization as export. His presentation is on a working flow chart for a good research from the beginning till the end of the research. So please, Prof, start. The mic with you. Prof Faruqi.
Assalamualaikum.
Yes.
Yes, please start.
Should I start? Hello. Today I have two different Hello. Hello.
Yes,
Ah,
Prof.
Yeah,
Yes,
should I
you can
start?
start, please. Yes,
Yes.
start.
So today I'm going to discuss research proposal, how we prepare a research proposal. The flow chart is in on your screens. If you see, when we are writing this research proposal, the first thing that we write, we have to keep in mind three questions which are there: uh, what, why, and how. These three questions, when we answer, our research proposal will be ready. So what do we write in what? The question what that it comes, that is what is your research question? What exactly you want to do, and what exactly is actually your research problem? That has to be that has to be defined, and the proposal heading has to be given. And when you say why, what made you decide on this particular topic, and why it is of any importance to academics or the society in general. These two questions have to be answered. Let's say, for example, I'm talking about you may do a research on the effect of COVID on the economy of the country, your country, Oman, how it has affected the economy, how the oil supplies have been affected, how much, what are the revenue losses, what are the uh, gains also because of COVID. Let us say, for example, because of COVID, maybe the sales of dates might have increased, or something might have increased, something might have happened, which helped the economy in some other way. But on the whole, if you see, if you have read the information throughout of the entire world, you might have come across the news that GDP of almost every country has gone down during last 8 or 9 months because of COVID. So because everywhere there were lockdowns, there was no production, there was no sales, there were no interaction between the human beings, there was no business. So GDP had all been affected very badly. Now, obviously, when the whole world was suffering, your country could not have been an exception. There must have been some slip up in the GDP. Now, after that, you have to write a small summary of what exactly is the proposal, what are the things which you plan to do, and the introduction of the entire work that you are doing, and how are you going to conduct your research. See, research, uh, are you going to have your research based on primary data or the secondary data? If it is primary data, what type of sampling method you are going to use, whether it is simple random sampling or stratified sampling or probability sampling or non-probability sampling, or whatever the entire gamut of sampling methods. You have to discuss what exactly, which method you are going to use, and why are you going to use this particular sampling method. After doing in the same how, answering how, you're going to speak about the other research methodology, what analysis you are going to do, how are you going to arrive at different what tests you are going to conduct, statistical tests that you are going to conduct to arrive at the final conclusion. So all this has to be discussed in the first part, that is introduction. All these three questions have to be answered in detail. See, how has to be answered in detail. Then the after writing this part, the next part that you are going to do is the literature review. Now, review of literature, there are two questions which you have to answer: why and what, how. Now, uh, in why, we answer the question, uh, uh, we first talk about what is the literature available on this particular topic that I have selected. Why we are going to do that? Because that will give you a straight line to follow for your own research. So you are actually saying that this much work has been done, and now the further work that has to be done, that is going to be done by me, or means the researcher. Then the methods that you are going to use in answering your how in introduction, when you answered the how, you talked about research methodology. So why means what is the literature available on the method, how, what all things are available, and who all have done their work, and also your theoretical approach that you are going to take about the whole problem. Then in answering how, you first answer in the existing research that has been done on the topic, what are the holes, what is missing, what all things can be done further, and also where is the database that is available, how are you going to collect the database, and from where are you going to collect the database. If it is secondary data, what are going to be the sources, which are the sources which are actually giving you the secondary data, and in the say and why are you choosing that particular database. See, there are for any economy or any research for that matter, even socio-economic or psychological researches in any social sciences, or even in natural sciences or physical sciences, uh, a lot of database is available from different sources. Some of these sources are genuine, they are right, and some of them have been generated. I'll give you the example how actually they are being generated, they are being sponsored. Even on Google, if you see, there are websites where the research has been done for, which says that tea is good for health, whereas coffee is bad. Now, this research, if you look at it minutely, you'll realize that this has been done by the association controlling tea production in United States. Whereas there is another group in the same Google, on the same Google page, you will find there is another group which says, another research which says coffee is good for health, whereas tea is bad. Now, this has been done by Coffee Board. This research has been sponsored by, so there is a lot of sponsored research, and quoting from this sponsored research may give you a biased result, and thereby, making all your efforts go waste. Therefore, your database has to come from an unbiased source. It has to come from a source which is recognized by the authorities or by the scholars, and not by anyone. I may talk about a lot of things on earth without actually knowing about them. So my voice should not count on those matters. My voice should count on something which I'm good at. So these two, after answering these two, we go to the next part of research proposal. That is the methodology. What methodology you are going to adopt? There, the first thing that you have to talk about is the research design. Now, the research design, uh, what processes are going to be there, the research procedures, the data that you are interested in, kind of data, whether it is uh, uh, the quantitative data or qualitative data, or it is primary data or secondary data, or it is data sourced from uh, experts only, and not the common man who is actually user. Let's say, for example, we talk about we talk about uh, airplane air travel. Air travel, we can take the survey of all those air travelers over the years, or different periods of times, and take their means what are their opinions about it. On the other hand, if you are talking about air travel, we can
we can take the survey of all those air travelers over the years or
so
different periods
they,
of time and take
so
their what are their opinions about it.
now these air travelers may not be able to give you the technical details. Whereas if you ask, if you are interested in technical details along with the air travel, what are the technical details required, then you have to go to the experts who are actually like pilots who are actually handling the aircrafts, or you can talk to the engineers working on the aircrafts. So they will be able to give you the technical details. Or if sometimes you are not interested in even in the technical details, you are interested in the management details. So even the aircraft engineers will not be able to tell you what and how. So there you have to speak to those who are actually maintaining the rosters, who are maintaining the accounts, who are maintaining the purchase and sales and all those management details that you can. So there you, whom are you going to, what procedure you are going to follow. Now you cannot ask questions to all the different stakeholders of a particular industry in the same manner. See, questionnaire method is one of the most popular methods in research methodology, but still that has got its own limitations, because as a ordinary citizen, as someone who knows about air travel only on the basis of what I have, how I have traveled, I don't know the technical details. So when I am going to speak to the technical person, my questionnaire may not be fully prepared for that. So what type of, how am I going to collect the data? Will it be a questionnaire, or should I allow the person to speak on his own and give me all the technical details? What are the things which are involved? So those things actually, so how the data collection procedure has to be done, that also has to be stated clearly. Then the selection and the access that we have to the data, how what all things, see, it happens that I want to know something about the Indian economy. The Indian economy I can speak to, or any country's economy, I can speak to the uh, different economists. I can speak to the common man also about how he's facing the economy. What are the problems being faced by the common man? I can speak to the economists. I can speak to the bureaucrats who are handling the economy. I can also speak to so what my selection has to be important. Whom am I going to select to collect my information? Will it be the common man to just understand how things are moving? Is there more unemployment? Are the prices increasing? These things common man can tell me. But when it comes to, let us say, something more, how industries are actually doing, what are the things which industries are, or what problems industries are facing if the country, if the economy is not doing well, if the industries are not doing well, common man will not be able to tell me what problems the industry is facing. So I have to speak to someone, some insider, some industry man, and speak to him what are the problems faced by his industry. Let us say auto industry in United States is facing a big problem because of competition from uh, the Japanese, Korean, and this German cars. So I have to find out, if I want to know what are the problems being faced by this in American auto industry. I have to speak to someone who is in the know. So that selection has to be done. And do I have the access to such a person? Then the next question: can I meet such a person? This happens industrialists sometimes when they have work, they are accessible. That is there. But it happens when you are asking the you know main decision makers anywhere, whether in the industry or even at the country level. I want to know something about Indian economy, and there the problem is with the which can be explained to me either by the finance secretary or finance minister or the prime minister. I don't have access to them. It is impossible because they are so busy. They don't have time for an ordinary researcher like me, for a student like me. So then access becomes difficult. Then in that case, if I don't have access to these people, who are the second best, I have to find before. When I'm writing, I must know, and I must when I'm writing my research proposal, I must know, and I must mention that whom am I going to contact. Then uh, in connection with my subtopic, which whatever research topic that I have selected, is there a human touch? Is there a human interest value? Let us say when I talked about economy has got a lot of human interest values, because if the economy is not doing well, there will be unemployment. If the economy is not doing well, there may be inflation. If the economy is not doing well, there may be civil disturbances. So I have to study that what in one particular in my particular problem, how actually human interest values are there. Those that also has to be discussed, because I'm why I have to say all this, because ultimately my research is going to give a solution to the problem that I'm talking about. My ultimate objective is to give a solution. So therefore, you can give the solution only if you know the problem and you have a problem in your mind, which you have mentioned. Then
so
the
please,
ethical.
Prof,
Yes.
Prof, please, the time. Please try to make
Just 5 minutes. Just 5 minutes. I'm
summarize.
finishing. Yes.
Thanks,
Ethics are
thanks a lot.
important. I've used somebody else's research, I have to mention that. References have to be given. Cost and funding has to be given. Then preliminary data. What are the sources? Evidence of importance of what the data that I've collected.
Dr.
Sir.
Dr. Farooqi, I would request, please, just consider the time limit also. We have a limited time.
I've got 3 minutes
To
left. I'm
wind up.
finishing in 3 minutes. Sir,
Please.
I'm finishing in 3 minutes. So in methodology has to be given, and then statement of limitations. What are the limitations of your problem? That you have to mention in very clear words. And then what are the weaknesses where you went, where you might have gone wrong. You have gone wrong. I'm not saying where you might have gone wrong. That also has to be mentioned. And ultimately, you go for the conclusion where you are writing all the contributions, how, why, all these questions have to be answered, and importance of your research, how it is going to help the society or the subject in general effect. Thank you very much for being so cooperative with me. Thank you. Thanks a lot.
Thanks a lot, Prof. And also, we are sorry because the time is going fast.
No, I understand.
So thanks with a good and excellent presentation. Just only I want to mention about Prof. He has a very good experience in practical research. Thanks for a nice presentation. Now we invite the second speaker. Let us to invite Anjun Ara Ahmed to start her presentation on formulation and solution of a real problem using statistical tools. So you can start, Doctor, please.
Good afternoon, everyone. I hope you all can hear me.
Yes, we hear you. Continue.
Thank you. I'll just share the screen.
Dr. Anjum, share your own screen.
Share your
Yes.
screen. Okay, it's clear. So
Thank you.
go ahead.
Yeah, actually, I have discussed my problem. I have slightly changed testing of hypothesis, and I will also be taking a real problem, which has
Any
been.
problem?
Hello? No, sir, you can hear me?
That's okay.
Yeah. So my basic topic is testing of hypothesis, and I'll be taking a few problems to
No, it's
handle
okay.
this.
Your screen is visible.
Yes, sir. So, so my name is Dr. Anjumara Ahmed, and I'm at present the principal in charge and associate professor of statistics in Degree College of Arts, Science, and Commerce. Just a brief. Now, basically, I'll be talking about testing of hypothesis. So there are mainly two type of hypothesis. Now, what is hypothesis? For a layman, hypothesis is basically a statement, a problem. Whatever is your problem, the statement of that problem is called hypothesis. So in statistics term, we say hypothesis, and this is very important in any research you can say. So when you say about hypothesis, we have two hypotheses. One is null hypothesis, and one is alternative hypothesis. Now, null hypothesis is basically when we say there is no significant or no statistical relationship. When we assume that there's nothing is there. So this is one major problem which I find people do not understand the difference between null and alternative hypothesis. So they whenever if you are saying null, it should say no statistical relationship or no significant difference, whichever way you say. So mainly people have relationship between the central value or mean, or they try to compare two means. These type of problems are there in normal research. So if we are comparing, like suppose I'm comparing a class is there, a class of students is there, and I want to say that the height of students in that class is 165 centimeters, for example, or 170 centimeters. So my my population, and based on that we do sample study. We want to check whether you want to, the mean of that is 170. Hello?
Dr. Arab, please, all our participation and speakers, please mute your sound, please, if it's your microphone soon as possible, please. So
I
go
can.
ahead. Sorry,
Yes,
sorry,
no
because
problem.
some people they open the speaker, so it
Yes,
makes
sir.
problems. So just I want them to mute it if it's possible, please.
Yes, sir.
So go
So
ahead. And
yes,
I'm
so
sorry, I'm overly
no,
sorry.
no,
Go
no
ahead.
problem. So null hypothesis, basically, this is very, it has to be clear. Whenever we say null hypothesis, it should be no significant relationship. Means we will start with equal to. Means suppose mean is equal to 165. This is a major thing when we say, whenever we do the study. I find that people do not understand what is null hypothesis. And when you say alternative hypothesis, the other part, then it is just, it can be, there you have a choice. It can be that the height is less than 165 centimeters, it can be more than 165 6 centimeter, or not equal to 165 centimeters. So that is very, very important to understand null hypothesis and alternate hypothesis. So we have a choice in alternative hypothesis. It can be one-tailed or two-tailed. When we say one-tailed, means it can be less than equal to, or it can be greater than equal to. When we say two-tailed, then it has to be not equal to. So these are the different types of alternative hypothesis. It can be less than equal to, it can be greater than equal to, and it can be not equal to. So this is mainly, so as I said, it can be less than equal to 165 centimeters. Your average height can be more than equal to 165 centimeters, or it can be not equal to 165 centimeters. So basically, this is as far as hypothesis framing is concerned. If you have framed your hypothesis correctly, then only you can go ahead. So in a research, framing of hypothesis is very, very, very important. Now, when you have framed your hypothesis, as I say, we do any research to understand what will be the result. Okay, so we test it. So whenever you are testing the hypothesis, then there can be many errors. So basically, we have you are either taking a correct decision or you are taking a wrong decision. Correct decision can be the hypothesis is wrong and you have rejected. Another corrected decision is that the hypothesis is correct and you have accepted it. These are two correct decisions. But there are wrong decisions also. And that is what is called types of error. Okay, so types of error basically are of two types. One is type 1 error and one is type 2 error. Type 1 error means you are rejecting the null hypothesis when the hypothesis is true. You are rejecting the null hypothesis when the hypothesis is true. So this error, the probability of this error is called alpha. This is very, very important because this decides your significance level of test. I mean, what is the level? And that is generally denoted by alpha. Alpha is very important in any testing of hypothesis because this defines what will be your rejection area and what will be your acceptance area. Alpha generally is taken as 5%, it is taken as 10%. So alpha can be 0.05, it is 10%, it can be 0.1, it can be even 1%. Nowadays, people don't take 10%, people generally take 5% or 1%. Standard mostly in social sciences, they take 5% level of significance. And when there's medical sciences and all, people take 1% because there's the error. Taking a large error is it can be very, very dangerous for the result. So they take 1%. Mostly in social sciences, people do research, they take 5%. And type 2 error is the error that the null hypothesis is rejected when it is not true. Means yeah, sorry, accepted when that it is not true. That is what is called beta. There's an error here in writing. So 1 minus beta is basically probability of accepting the null hypothesis when it is true, and that is what is called the power of the test. So we are interested basically in type 1 error, and we are interested in what is the power of the test. And many times in many problems they also call the level of confidence. I mean 99% confidence in 1% level of significance and 95% confidence in 5% level of significance. So these are the broad categories which our researchers should know. What is your null hypothesis? What is your alternative hypothesis? What is alpha? Alpha is very important. We have to always have to fix the type 1 error. We don't fix type 2 error, we fix type 1 error. And alpha is always fixed, and mostly it is fixed as 5% or it is fixed at 1%. Okay, let us go. Now, since there is limitation of time, so I will be basically handling mainly two type of test. One is T test and one is Z test. Basically, they both lie on the same ground. And if you are using software like SPSS and all, then mostly it happens that T test and F test both are done through in the same thing. They don't specify T test and test separately. But if you're doing by using formula, then you will find that the formulas are different for T test and Z test. But the basic background are both are parametric test, and one is used for small data and one is used for large data. T test is generally used for small data and Z test is used for large data. So if there's a number called 30, 30 is a magic number, you can say. Generally, people say that if the number is more than 30, then we should go for Z test. And if number is less than sample size, number means sample size, is less than 30, then we should go for T test. So these are the things. Now there are mainly three T test. We basically have three types of problem. One is one sample T test, one is two sample T test, and once we take the difference. One sample means the mean is mu is equal to mu naught. Means you are testing the mean. So basically you are testing the mean that you are comparing with the sample mean, the population mean. So whenever you are doing, and as I said, we use this only for small sample size. So one sample t test is basically used when mu is equal to mu naught. An alternative hypothesis can be either less than equal to mu naught, greater than equal to mu naught, or not equal to mu naught. So mu less than equal to mu naught and greater than equal to mu naught are one tail test, and not equal to mu naught is called two tail test. Why they are called one tail and two tail? That is the main thing you should understand. So that is that because that defines your critical region or critical value. What is critical value? Critical value is basically, critical region is a region which defines what is your acceptance or rejection area. So critical region is where if it falls in that, if your value falls in that area, then you reject the null hypothesis. So this region usually as I said, one-sided or two-sided. And nowadays, instead of finding the value in a computer base, they take p value. So p value is based also depends on alpha. So if p value based on your alpha, you have to define your p value. So generally, if p value is very low, it is reverse. You reject the hypothesis. So p low in normal language we say p low h not go. This is the normal way people learn to understand how to reject. So p value is given mostly by computers, and critical region you can use you can find by using the various tables. So if you see this, now this is your t-test data, because in t-test, if it falls in this region, this is one-sided t-test, left-sided test. So the if example is for n is 20, in t-test, depending on n, your table changes. So here, if it is falling in this region, then you say that you reject the hypothesis. So minus 1.1725. So if the value is lesser than this, then you will find that the hypothesis has to be rejected. If it is on this side, 5% level of significance, 1.725 is the value. So if t values, your calculated t values is more than 1.725, then you reject your null hypothesis. Generally, what people do, instead of not understanding it, they take absolute value. Absolute value is greater than your calculated value, then we basically reject the null hypothesis. So same way, but if it is two-tailed test, then your alpha by 2 we take. So this is 0.05 and 0.05. So your value is change here, minus 2.04 and 2.04. And then if it follows in this, it falls, if your value, if your t value fall in this region, then we basically again reject your hypothesis. Again, I'm saying you can take the positive value, and then if it is more, if you take positive, then if it is more than 2.024, then you reject the null hypothesis. So two-tailed test, it is changing. So just if you put in this way, mu less than mu naught, then you can see minus t point alpha. If it is lower than this value, you reject h naught. If it is mu greater than mu naught, right side test, then if it falls in this region, t alpha value is this, and if your t value is more than this, so you reject. And if it is a two-tailed test, then if it rise, if the value is this side or in this side, means if the modulus value is more than t alpha by 2, then you reject the null hypothesis. So this is how the critical region or the rejection is considered as far as the, and as I said, p value is the probability of obtaining, means this is given in mostly by computer, and if p value is lesser than alpha, mean the null hypothesis is to be rejected. So it is slightly reverse. Here it is there you reject if the t calculated is, if it calculated is more than t alpha. Here if it is p value is less than alpha, then you the null hypothesis is rejected. Means suppose if p value is 0.05, suppose the alpha is 0.05, and if the value is less, suppose 0.00001, then you should reject the null hypothesis. So if p value is very small, then hypothesis is rejected, and here if it is more, it is rejected. So the way how you look at p value is different. Now let us take a simple formula of t statistics. T statistics is basically difference between whatever is your x bar minus mu divided by your standard error. So standard error, if it is a sample value, then it is root n. So x bar minus mu upon s by root n is the formula. What are the assumptions for t-test? We need data values. It should be independent. It should be continuous data, simple random sample, and population should be assumed to be normal distribution. T is taken when the sample size is less. So this is basically as far as the t-test is concerned. Now let us take one example. 31 energy bars from a different store. Population of energy bars is available for a general consumer. These are 20 grams of proteins are there. The grams of proteins in all these 31 bars is written here. Grams of protein 20.7, 27.7. So basically you are given the 31 energy bars and their grams of protein. Now I want to check. Okay, so I will find out that my formula is this. We have to start, we have to take the difference to 21 minus 4, so 1.4 suppose, and what we will do, we'll find the standard error, normal formula, standard deviation formula, divided by root n. My value is 0.456. Now 1.4 I will divide by 0.456, so 3.07. So now my t value, I will this is your t value, this value, and then alpha is 0.05, and number of this degree of freedom will be 31 minus 1, n minus 1, because here it is a sample be minus 1, so 30. So your since we are saying your null hypothesis is not equal to, you have not specified, but in this problem, if we take the null hypothesis as not equal to, so I've already defined that in this problem, 2 point, sorry, the value is the value is coming to be 2.043. So if my for 30 degrees of freedom, my value is 2.03, so plus minus, so my 3.07 value is more than 2.043, so I will reject my hypothesis. So this is calculated by using my the t table. Okay. So if I have sample t test, generally people do sample, your example is done using sample study. So x minus mu naught upon s upon root n. So degrees of freedom is n minus 1. Two sample tests. Two sample test means you are comparing one with the other. I mean one class, maybe two different stores are there. So we can compare the one protein bar and average and the second one. So x bar minus x bar 2 it becomes, and standard deviation of S1, S2, root of 1 upon N1 plus 1 upon N2. Your degree of freedom is N1 plus N2 minus 2. And pair t-test is basically taken when you have same sample, but we are doing something on that sample. Like suppose nowadays COVID, suppose we have a placebo, we are trying to find some immunity test, we want to check whether particular injection or we give to the person, so what is the effect. So we can say before and after. So that difference paired. So same, the sample is not changed here. Here the sample is same. So same sample, before and after, we will take the difference, and then we will see whether what is the success, what is the difference is more or less or not equal to, depending on your null hypothesis or the alternative hypothesis. In null hypothesis, we assume will no difference, but in alternative hypothesis, we will assume that whether the difference are more or it is less or not equal to, and then that's why the degree of freedom is n minus 1 only. So pair t test basically sees the before and after effect. Like people have lot of nowadays people have lot of they take uh, reducing the weight conscious people also, they want to see, take some and then check whether after the treatment they have reduced weight or not. So they can, so some they can check whether before and after what is the difference, whether it is significantly the weight has reduced or weight has not reduced. That way also, just an example I'm giving. So t-test can be used for pairing. So formula is x bar minus mu upon standard deviation divided by root n. So what I mean to say, the formula is not different. T-test formula is same. But the only thing is that depending on the type of test, whether you are doing one mean or you are comparing two mean mean two different population. Please understand. And two different samples. And pair t-test, here the sample is same. So all these are pair t-test is or before and after effect. You are given some treatment and we check what will be after the treatment. Okay, I hope it is clear. So here different type of test, again I am repeating. One test mu h नॉट नहीं आएगा यहाँ पे h1 आएगा greater than or less than equal to, and then the formula two sample t test x bar minus s2 sp. This is the formula if someone wants to note down. 1 upon n1 plus 1 upon n2, degrees of freedom n1 plus n2 minus 2, and standard deviation is n1 minus 1, n2 minus 2, n1 plus n2 minus 2. This is basically your formula. This is as far as t test is concerned. So later on, if we go for z test, z test is similar to t test, but there if we follow normal distribution, and this is the most common test when as far as testing of hypothesis is concerned. Here we say that here we have, if you have one sample z test, then you will find that more, as I said, mostly we take when the sample is more than 30. How do we run Z test? Same way, you have to choose alpha. Now Z test has slightly easier way. You don't have to always see the table. Some you the table, you have to see the table, but some values of alpha is known to people, and you can learn also then, because here it does not vary for n. It is independent of n. So directly Z test follows Z normal distribution with mean 0 and standard deviation 1. And standard normal SNV it is called. Standard normal table values are given and available. So it is very easy to use Z test. Z formula x bar minus mu upon sigma upon root n. You can see formula is not much different. X bar is sample population mean, population standard deviation, sample size. Now here, as I said, confidence interval is very important. I'll go on to this later on. So confidence interval, you have to understand this table. Now this is your mean. Now if I say 99%, 1 sigma, confidence interval is sigma limit. 1 sigma means 68% of data lies in that range. 2 sigma means 95% data lies on this. And 3 sigma means 99.7% data lies on this. People generally ask, what is your 95% confidence limit? What is your, so this is very important. People want to know what is the sigma limit, 99% or 99, 95%. So 3 sigma limit, 2 sigma limit, 1 sigma limit. Nowadays people talk about, so 3 sigma and 3 sigma become 6 sigma limit. So the accuracy level has to increase. So if we have 68% confidence limit, then we will take Z score of -1 to +1. 95% then -2 to +2, and 99.7% confidence limit, then -3 to +3. Means this is what is called basically the 6 sigma, means 3 sigma this side on the negative side, and then 99.7% you are confident that the data is in the acceptance area. I hope, like suppose if you are producing bulb or you are producing medicine or something, then the higher level of confidence interval is accepted. That is accepted from the people. Now, normal distribution curve. Normal distribution curve is not touching. It is unending, minus infinity to plus infinity. Here, if I take 5% on the right side, then my value is, it comes to be 1.6.
Excuse me, doctor.
Yes.
Excuse me, doctor. Could you please summarize your presentation, please?
Yes.
Respect the time, please.
Yes.
Thanks a lot. Thanks a lot.
Thank you. So 5% basically is minus 1.64, 1.74, 1% minus 2.33 plus 0.33, and if you go more lower, then it becomes. So this way, it is already summarizing only. So when you have, if you have a large sample, then it is preferable that you go for Z test, and you can find your value. If you reject the hypothesis, if it goes in the tail value, and depending on your 5% and 1%, you can learn, you can understand the value. If you take 5%, 1.96 is for two tail, 1.64 for one tail, and minus 1.64. So it is quite easy to use Z table if your data is more than 30. So you accept and reject based on your based on where your value is coming. Thank you very much. I hope I have made people understand a brief of testing of hypothesis. It is a very elaborate topic. We can just think this can be a little basic of what is testing of hypothesis. Thank you very much.
Thanks a lot, Dr. Anjum Ara Ahmed. She has a lot of work on a factor analysis and testing of hypothesis. Thanks a lot for a good presentation. Now to save the time, we just let us to invite Dr. Hussam Sadiq from Department of Mathematics and Science, CAS Dhofar University, Salalah. So please start, Dr. Hussam.
Thank you very much, Dr. Musallam. Let me just share my screen for a moment.
We are hearing you, so you can sharing the screen, please. Yes, Dr. Hussam?
Yeah, just give me 1 second to share my screen. I have something here in the settings that I will do quickly.
Okay, take your time. Yes, Dr. Hussam, start. Okay.
Okay, thank you very much for joining us in this symposium in this wonderful afternoon. My session will be on questionnaire design. I will jump right into the topic because we don't have a lot of time. So I would like to start my presentation by answering the basic question why we need to design a questionnaire. The more often than not in our research, we want to study the relationship between a target variable and a number of other variables called auxiliary variables. And in these situations, if I give an example of a social science researcher who wants to study the factors that lead to psychological disorder, with psychological disorder being the target variable here, then the researcher might just limit this investigation to a number of limited social demographic variables, such as age, marital status, and education, just to name a few as an example. And if that's the case, the research in question may not be conducted unless data are available for both the target variable and the auxiliary variables. So in other words, the values of the auxiliary variables must be measured for a sample of individuals, and also the values of the target variable, which is psychological disorder. In this case, they must also be measured for the exact same sampled units. Now, to answer the question that I began with, the questionnaire is the instrument that measures these values. It is what we use to obtain the values of our variables in the research. So that brings me to this slide, which posing this question: what is the questionnaire exactly? The questionnaire is that measurement device that we use to measure the variables in a study or a research. But let me tell you this, it is an imperfect device. So why am I saying this? It is an imperfect, because you will never find a single one questionnaire in the whole world that will measure the values of your variables with 100% accuracy. This will never happen. So maybe this is something that you might be borne in mind as we speak. And from experience and years for developing questionnaire forms, we come to realize that designing the questionnaire is both art and a skill. But I would like to argue with confidence, it is also a science. The reason I'm saying that it is a science, because it is for decades and decades, statisticians and researchers in the social science discipline, they cannot come up with a standardized, universally single method or approach to design a good questionnaire. But in recent years, or recent decades rather, the researchers, they laid the foundations for a set of principles that if we follow, then we will produce a questionnaire with very high accuracy. This presentation is about these principles. I would like to share with you some of these principles, which are considered as a rule of thumb when it comes to designing the questionnaire. Now, I appreciate that the audience might have heard this about 1,000,000 times before in your life, but I insist to include this slide in my presentation, which is about the types of questions that one can include in a questionnaire form. There are two types of questions in general that one can include in a questionnaire. The first one is an open-ended types of questions. And in an open-ended type of question, we just ask the respondents or our sample members a question, and then we allow them to answer that question using their own words in any direction that they want, using their own imagination or even whatever that just comes to mind, really. If you check with me this example here, what do you think about Apple products like MacBook, iPhones, and so on? And you just leave the respondent to answer that. That is an open-ended question. But my presentation today is not an open-ended question. It is on the second type of questions, which is closed-ended questions. In a closed-ended question, we force, rather, the respondent to choose one of a set of provided answers. Like if you ask the respondent, what is your marital status? I'm using very basic and simple examples, of course. Then they have to choose between married, single, divorced, and widowed. So if the presentation is going to be about the closed-ended questions, there are a number of types of those questions. I put on this slide the top 3 of these. A closed-ended question, and if you listen good, it could be one of the following. It is either dichotomous question or a rating question or a Likert scale, the popular type of questions, of course, in social science. Or a dichotomous question is a question that with just a couple of answers, they are mutually exclusive. You usually see things like yes or no, true or false type of answers. Like if you check out this example that I have here, have you been on a boat before? And then you provide answers like yes or no. But a rating question is also interesting. These are the type of questions that you see when you visit a private clinic or a large supermarket, and they ask you, how would you rate our services today? And then you could just say good, fair, poor, or very poor, maybe excellent, very excellent, and things like that. But the most important one of these types of questions is the Likert scale. It is the one at the bottom of the screen that's before you right now. The Likert scale is the one that we use when we need to design a measurement scale for abstract phenomena in social science. Take, for an instance, intelligence. If you want to measure intelligence, that's an abstract phenomenon. Then you might need to design a scale to measure that. Usually when we design a scale for that, we pose a set of questions, usually 15, 20, 25, depending on the phenomena under study. But the most important thing, the answers provided to that and the question will be in a form of a statement like the following one. This topic is very useful in social science research. Of course, you will strongly agree. So these are the range of the questions ranging from strongly agree to strongly disagree. That is the Likert scale type of question. Unfortunately, we will not have the time to discuss that in detail, but these are just the main type of questions that one can include in a questionnaire. Now, let's jump right into it. How do we design a questionnaire in general? A good questionnaire, it's designed if it is going through 4 main steps. Those steps are, the first one is designing the question text itself, and then designing the provided answers, and then deciding on the structure, the arrangement of the questions inside this questionnaire. And then finally, of course, testing the design questionnaire. So if I begin by the first one, which is designing the question text, researchers in social science and statistics as well, they agreed upon a set of things that must be avoided when you design your questions. So you have to be aware of these things so you can avoid them when you're writing questions in your questionnaire. The very first thing is that avoid using unfamiliar wording. And when I say unfamiliar wording, if I give you an example, check out this example here. Do you think that high BMI is associated with the likelihood of being depressed? Well, if you ask that question to members of the public, it will be very difficult for them to know what the expression BMI stands for. In fact, it wasn't until recently, until I knew that BMI means body mass index. Even then, it was hard for me to answer the question. A second thing that you need to avoid is using indefinite words. You do not use indefinite words in your questions. Words like usually, recently, often. If you look at my following example, it says that, have you recently been to the gym, or have you recently been to the doctor? Well, the word recently here to you might mean the past 2 weeks. To me, recently means the last 3 years of my life. So how would we answer this question in the same way, me and you? So we also need to avoid long question text. We want the question to be straight to the point, just giving the respondents the chance to understand it. But if the question is too long, the sample members will keep missing the point of the question. Look at this example here. In the past 7 days, did you visit any local hospital for which you intended to carry out a blood test for a particular disease that had been irritating you for a period of time that is not longer than 2 years, and for which you had never been to see a doctor for a normal checkup? What is the question? I want to answer this question, but what is the question? So you keep missing the point if the question text is too long. So this is one thing that you need to avoid as well. You also need to avoid leading questions, and leading questions will be in the following form. So if you ask someone, do you agree with the majority of people that physical punishment is bad for children? If you ask me this question and my answer should be no, I don't agree, I would be forced to say yes, just because you use the expression the majority of people. If the majority of people are saying one thing, I want to be with the majority of people. I don't want to be alone. So you will get an incorrect answer by asking leading questions. They lead you to one direction. Also, I would like to say we need to avoid asking double questions. Things in the questionnaire need to be asked one at a time. A double question will be in the following form. Do you think that people must eat less and exercise more? So what if I think that people must eat less, but not necessarily exercise more? What should my answer be? Yes or no? Both answers are correct. So that the problem here is the double questioning thing. We also need to avoid asking things that people don't know. Sometimes we feel the need to ask people about things that we think that are important in our research, but that should not happen. Look at this question here. Can you explain to me how a nuclear weapon is constructed? Or can you tell me how a brain surgery is performed? Can you imagine ask that question to members of the public? You would not get an answer. So unless this is very important in your research, you don't want to ask these types of questions to respondents. You also don't want to ask hypothetical questions. Why is that? Because people, they find it very hard to form a memory or imagine things right at the spot. So if you ask me the following question, for example, if you were the president of Sudan, that is my country, what would you do to fight illegal immigration? I think if I was the president of Sudan, the last thing I would be thinking about is fighting illegal immigration. There are other things that I need to worry about. So that is a hypothetical question. You need to avoid it. Asking negative questions. Check out this question here. Are you against a ban on smoking? That is very confusing. Am I against a ban on smoking? It is difficult to understand the point of the question here. Even more difficult if you have a double negative question, like this one. Are you not against a ban on smoking in public places? So I have to pause a second here and think, am I not against a ban on smoking in public places? So you're making it difficult for the responder to get the point of the question. And instead of that, you should put the question in a positive statement rather than negative one. Sensitive questions should be avoided unless it is vital and important in your research. So questions like things, if you ask people, have you been to prison before? Have you been to jail? Do you have HIV? That will cause the respondent either to say no, even if they're lying, or stop the interview and quit. So unless this is the subject that you are studying, you want to avoid putting the question in this way unless you want to reduce the sensitivity of the question. I'll move now to the answer type. Once you finish writing the question text, you have to provide a set of answers for a closed-ended question. The answers must be mutually exclusive. They also must contain enough variability to allow respondents to select the correct and appropriate answer. So what do I mean when I say they should be mutually exclusive? They should be separate, no intersection or overlapping amongst the provided answers. If you check my example here, what type of TV programs do you watch the most? Music, sport, news, drama. What if I watch shows on politics? My answer is not there because you don't allow for enough variability in the answers and the list is not enough. One way out of this to deal with that, if the list is too long and you don't want to write everything, you can allow for the popular option that other, please specify. People usually do that. Other, please specify. So that's fine. But then you will then have another problem because remember, in a questionnaire form, sometimes people are allowed to pick one answer. In other type of questions, they are allowed to pick more than one answer. It is the famous tick all that applies type of questions. So if you are asking respondents about the type of symptoms they have for a disease, you can list symptoms, a large list of symptoms. Usually respondents stop ticking after they tick one or two. So even if they have other symptoms, they stop just after ticking a few. So how do you deal with that? Other, please specify will not help you in this scenario because you already provided a list. The one way we deal with that is to design a radio button type of question. So you give a yes or no answer to each option, and then respondents will say headache, yes, no, and then they will answer the whole question just by ticking on the whole list, and that will solve the problem. The third step in designing the questionnaire is the structure of the questionnaire form. After you design your questions and your answers, you have to think a little bit about the way that you will arrange those questions in the questionnaire form. Why is that important? Because you want the question and answer process to be interesting, easy, and enjoyable for your sample members. You don't want them to stop after answering a few questions. So things that you need to pay attention to in this case are the following. Grouping similar questions in one section. If you have a set of questions about socio-demographic factors like age, gender, profession, and so on, put those in one place. People usually enjoy telling about themselves, about my position, my profession, my marital status. Put them together. They will like that. You also need to think about the learning effect. Let's stop for a second here, and let me tell you what a learning effect means. Some respondents, when they answer questions, they are slick. They learn from the answers they gave you in previous questions, and they use that to answer later questions, even if it is incorrect. Let me give you an example of that. Suppose that you are asking me the following questions. Now, if you pay attention with me here, look at this question here. Is there a health? Is there a playground in your neighborhood? And then I say, yes, there is. Are there any primary schools nearby? And then I say, yes. And then you follow that up with the following question. Do you like the neighborhood where you live? If I don't like it, I think I will say, yes, I do, because I don't want to seem unrealistic to you after admitting to all of these local surveys. Say no now. The best way to arrange these questions in a questionnaire would be to start by this last question. Do you like the neighborhood where you live? Then I can say no freely. And then you can ask me the rest of the questions. Another thing is consistency. You need to be consistent when arranging questions. If you are asking about diseases, put them together. Social demographic questions, put them together in one section. That is consistency. Also planning the route in the questionnaire form. What do we mean by that? Sometimes we don't want to ask every question in the questionnaire to everyone in our sample. Some questions are just designed for a specific type of questions. In this case, you have to introduce what is known as the filter question. A filter question is the question that classify sample members to you into 2 or more groups, so you can identify the group of people that you want to ask the next question. Like this example here. If you want to ask a woman about the age of her eldest child, it will be embarrassing to her if she doesn't have children. So maybe you want to ask if she has children before you can ask about the age of the eldest child. And that is the filter question. The question here at the top, do you have children? It is not essential to your research, but you put it in the questionnaire because you want to filter respondents. You want to identify the set of respondents that you want to talk to. If the answer is yes, look at the instructions between the brackets, then you will ask the next question. If the answer is no, you will skip the next question. So that is very good. Finally, after you finish writing the questions answers, and arranging the questions in the questionnaire, of course, you want to test it. Many researchers will not agree with me. They will say, we don't have time for testing the questionnaire. It will take time and money. But I'm just thinking, how would you be able to invest a lot of time in developing research questions, questionnaire form, collecting data, and you fail to specify a little amount of time for testing your questionnaire? Why is it important and why we need to test it? Because of the following. Will the questionnaire measure what it's supposed to measure? Sometimes it doesn't, and you wouldn't know that unless you test it. I will tell you how to test it in a minute, but I'm telling you now why it is important. Do respondents understand the questions in the same way that you understand them? How would you know that unless you test it? You wouldn't know it. Do we ask the right questions to the right people? And the only way to know these answers is to try the questionnaire out in practice, in reality. Just get a group of people, 5 people, family, friends, anyone, and just use it as a real interview and see if you can get the sense or a feeling that something gone wrong or something, then you can correct it. So what do you test exactly? If you want to test, this is what you look for. Number 1, validity. Validity means, do the questions measure what the researcher wants to measure? And that remind me for previous memory that before we asked pedestrians in a road about traffic jams. We're asking them, are there traffic jams in this road? And we use the expression heavy traffic. And the respondents, they thought that we're talking about large vehicles like lorries and trucks, while we mean traffic jams. So that is a completely different thing. It will get you measurement error. Also, family planning, if you ask housewives if they do planning and you mean saving from the monthly income, they might think that you are asking about the use of contraception methods. So that is validity. Also, you want to look at the fact that you have sufficient answer possibilities. You might give a long list to a question like, what do you do for a living? And you give an extensive list. Wonderful. But does financial analyst include accounting? Some people would not agree with you if you say yes. And finally, you want to know the length of your questionnaire. You will not be able to know how long the questionnaire takes in reality. If you write wonderful type of questions and you arrange them fantastically, maybe that question will take 2 hours. No one will have 2 hours to sit down with you and answer your questions. The only way you can find out about that if you try it in a real interview and see how long it takes. Actually, that's everything that I have for you in this wonderful symposium. Thank you very much for listening. Turning it back to you, Dr. Musallam.
Thanks a lot. Thanks a lot, Dr. Hussam. Thanks a lot with the nice presentation and the nice information. So now this symposium will highlight on the use of SPSS for a data analysis. So let us to invite Dr. Dhafir Mahdi, Department of Social Work, in a colleague of Arts and Applied Science, Dhafar University. So please, Dr. Dhafir, you can start. And thanks a lot, Dr.
Okay, thank you very much, Dr. Musallam. So today, actually, my topic is the use of SPSS for data analysis. I like to share my screen. Okay, yes, so for example, as Dr. Sadiq Hassan was explaining the questionnaire, close-ended questions, and open-ended. Generally, we use in social science SPSS for close-ended question. Once, can you hear me, everybody?
Yes, we hear you.
Yes, we can hear.
Okay, thank you very much. And so once we data collection is done, we completed the questionnaire, then we actually start to creating the data using this software, SPSS. So then how we use it, that I am actually, my topic for today is creating and analyzing the data using this software. Okay, so for example, the latest version of SPSS is 27, but in my computer it is 21. I am using this. And in a few minutes, I will show you the screen of SPSS. So basically, SPSS is a short for statistical package for the social sciences. And there are various kind of researchers, they are using this software. And this is actually, basically this software package was created for the management of statistical analysis for social sciences data. But also other researchers are actually, other researchers are also using software for the research purpose. For example, market researcher, health researchers, survey, different companies, the government, education researcher, health researcher. There are SPSS used by many different fields and departments and occupation. They are using SPSS for creating and analyzing data. Okay, for example, if you see these two slides, that SPSS screen has two views. I will show you in a few minutes. One is data view and one is data variable. For example, one here, if you see in the bottom, the data view, then you will see the cases. Cases are the respondent of the people who completed the questionnaire, and now it is the researcher's job to put all that data into the SPSS program. And at the top, in the second screen, there is a variable view. And here you can see the variable. For example, every question in a closed-ended questionnaire is a variable, for example. And then you can enter them. And once all data is entered and you define the variable and you completed all the the labels and the detail, I will show you in a few minutes, then you can start the analysis. For example, I can show you. Okay. I don't know what. Can you see the screen? Did something happen?
Yes, sir.
Okay. Hello? Okay. So here is the screen, and you can see the data view and the variable view. And if you see, this is the variable view. If you click this, it will show you this screen. So, and here are, for example, on data view and the top, if you see, there is a file and there are the different functions. You can, for example, upload the new data. You can use the syntax and open it and read the text detail and everything. These are different functions and you can use it as you require. Then there is the edit button. Also, you can insert variables, insert cases. These all functions, data. I will show you, I will open the other file and analyze. Then also there is a help button. If you have any kind of, for example, some point not very clear or you need to read something So there is all detail here. You want some statistic, you want some tutorials. All you don't, for example, don't need to Google something. Just click help button and whatever your topic is, you can find it, and it will open like encyclopedia of SPSS. So then you can find, and even the statistic coach is also available and you can use it. So now I can open, for example, here, if you, these are at this side is the cases, and this side, for example, rows, these are variables. Now I can, for example, here I can type a variable. For example, first question is how to the respondent. Then this is a variable one. You can fix it. Then next, for example, question is the gender. And then, for example, whatever your questions are, you can type here, education, and for example, occupation, whatever name, it is up to you. You can write it, it does not matter. Then if you click here, it will show you that all the variables, name, type, width, and it will come there, and then you can enter, for example, case number 1, for example, any example, right? For example, respondent 1 is Ali, you want to write name, and for example, B, C, and then you type their information, for example, age, gender, education. This is the way how we enter the data from the completed closed-ended questionnaire. Okay, so then once you have this, all the data, you complete all the questions put in the SPSS, for example, the file, and then save it. Data is saved, and then for example, then I will show you another file that is data is there. Then I can explain to you how data is like is saved or how data is used for analysis. So just I can open the other files. It's opening. Okay, for example, there are some variables given in this SPSS software. I actually collected some data, and then I just added few variables here. I have a larger file, but I'm not using that one. For example, here, if you see at the data view, age, gender, these are all variables: age, gender, marital status, father's education, mother's education, student GPA, and then, for example, how they do different function. We ask different question. Then here, for example, age, the student 1, the respondent 1 is the 20 years old, then 21. This is the age. Then gender, for example, we can label it. If you see the, for example, label here, if you go to variable view here, it shows that all the, for example, details of here, for example, age is label. If you want to, you can make it a little bit bigger, age of the respondent. This is the label. You can change it, you can type it. Here, gender of the student, you can, for example, value. Here you can write it, for example, 1 for male, add 2 for example, female. Some people use it 0, 1, it is up to the researcher. Then you say, okay. Then, for example, this is a you defined the gender. What is you mean? Because it depends on the questionnaire. If the questionnaire you wrote or the researcher wrote that 1 is male, answer 1 is for male and 2 is for female, so same way you have to enter the data in SPSS. And then, for example, marital status, married, here also you have to enter, for example, 1 for never married, capital, small, does not matter, you can make it 2, for example, married. So you can enter like that way. And then 3, for example, widowed. And then, for example, number 4 is, so as it is written on your questionnaire, so same way you have to label the variable. So this one, then, for example, okay, so once your data is done, and then you want descriptive statistics, so you have to go to analyze. Then here is a descriptive statistics. Under the descriptive statistic, you see here there is a frequencies, there is a descriptive explore, crosstab, graph, whatever you want, you can use it. For example, if I click frequency, so for example, here are some variables. I want to see, for example, gender of the student. So then I will say, I click this variable, then I will say, okay. And then this is the output of this variable. For example, some student did not answer the question, they missed it. Or maybe some error happened during when somebody was putting data inside. Actually, some student helped me to put this data in SPSS. So maybe there is something. And even I found that there are some questionnaire student missed this question and didn't click on male and female. So that's why just I put is -1, or you can say not answer, whatever you can do it. It's very easy. Then, for example, in this sample, 30 students were male student and 248 were the female. Total were 288 and 4 students did not answer. So for example, you can delete it. It's a kind of missing value, or there is something happen. I am not sure, but it is also possible that you can make some adjustment and you can maybe go back, check it. Maybe is the data entry error, or maybe something by the the respondent make answers, but doesn't. Okay, so then, for example, this is you can use another variable if you want descriptive frequency. For example, is the use of, for example, this is, I'm just sending this back to, only I want to grade, see how they showed the grade. When we ask this question that, for example, in last semester, what was your highest grade? So then, for example, they said, or maybe, for example, some people say 55, for example, out of 60 or 100, because when we did collected the data, semester was not complete. It was kind of midterm exam. So some student just randomly, I think they told us that what is the grade. We asked for the last semester, but some student probably in the questionnaire, they did not understand and they just said that. And later we found there were some errors. And that's why sometimes when questionnaire is, sometimes students or some people are not understanding very well, then we recommend best the interview. But generally, in the both way, you can use SPSS, but sometimes there are some errors. You can, a researcher can fix it. Okay, so then For example, here in analyze, so now I don't want to focus only on the frequencies. This is one of the way that you can take the frequency, and then also, for example, crosstab. If you want crosstab and you want to see the age of, for example, in here, you can see in one section rows gender, and maybe in the column you say, for example, marital status. Sorry, not here. Here you can say marital status. If you click OK, it will give you a crosstab. Then it shows that male and who is married, who is not married. Male, for example, nobody was, if never married, 19, married, widow, divorced. So this is the information. Female, and -1 is answer was they didn't click anything. They didn't show what was their marriage status. They were hiding, or they just by missed it, or maybe that was some problem. Maybe it was between not married, or maybe under divorce was under process. So I'm not sure, but that's why we put those kind of cases in the -1, that later we can find out that. So in this way, this is a frequency, and then you can include percentage as well. This is like a crosstab. If you want, if I go again, crosstab, and then here in this side, there is a, for example, there is a statistics. If you click statistics, here are these functions. You want to see correlation, you want to see chi-square test, and all these functions, whatever you like, you can just, for example, click. Anywhere you click, and then ask and continue, and then say, okay, it will give you the result of what is happening, what is the correlation, is there any relationship, there is a positive relationship between the two variables, there is a negative relationship. So everything SPSS will like show in the output, and then it's the researcher job to, for example, interpret the findings. And then, for example, I can just want to go back, cancel this, and then, for example, we don't need the output here. Under the analysis, if you see, for example, there is a correlate. If somebody want to see the correlation between two variables, bivariate, click here, and then, for example, here are the variables. For example, you want to see father's education and the grade of the student. You want to see that whether there is any impact or any influence of further education on students' grade, GPA, and then if you see, click OK, it will give you some kind of, whether it is a, for example, positive, negative, significant or not significant, but it depends on data, but the software will give you the output. Whether it is interpretable or you cannot interpret, there is some problem, there is no problem, but the software just will analyze the data. Not clear, you can, under the transform, you can recode the variable into same variable, into different variable. You can, for example, I can show you here, if you go to transform into different variable, click here and go to age. Here you can write, for example, respondent age, detail, age of, for example, I can write the new age, because already age variable there, it should not confuse old and new variable, like values. Here, for example, you have to, I can make a group. For example, I can say 16 to years old. Or maybe here 15, here you can write 20, value is 1, add it, And then here, for example, I can say 21, and then I can say under 40, for example, just one other value and highest, all other values, whatever you want. So then, for example, and value is 2, continue, then you can say, for example, change, okay. Then if you, for example, go back and see here, new variable is created here. For example, new age. And then if you want to see the frequency of this new variable, and then you have to bring this variable, I can put, for example, the grades back, that it's then new age here. And then it means that these are the values. There are some missing values, 14, maybe they didn't give the answer. And then one mean, for example, we made, if you see the label, it is a, and here we put 1, for example, 15 to 20 years old. Add 2, for example, 21 and above. Add, okay. So then if you make, again, the frequency of the same variable, so it will give you, for example, a new table showing there are 129 students are the respondent in this age group. And all others, I just, for as example, I combine them, 21 and above, there are 139 students, and this is the percentage. So this way, we can transform the data as according to our requirement. Sometimes data, for example, there is a missing data, there is some less number of cases. So then we can combine that, we can give when, because we want to see the relationship, then so we need to make some changes. But in software, it's very friendly and it's very helpful. And then you can use as is the needs of your research or your project. And here, for example, also other things, you can use regression analysis, log linear, and all other functions according to your need. Compare means, tables, graph, whatever you want. So just click the button and then follow the section. And then this is the way how we enter the data. And then we also, for example, analyze. So whatever is your question, what is your hypothesis, and whatever you want to check, then, for example, you can use SPSS and you can have the findings, and then you can interpret. So this is the way in the social sciences use this package, SPSS, for data analysis. Generally, SPS is not for qualitative data. It is only for quantitative data, and we only used questionnaire or interview for closed-ended question. So I think, so that's all. Thank you very much.
Thanks a lot, Dr. Zafir Mahdi, and for a nice and important part of our research, how to analyze the data by using the softwares. So now let us to invite Dr. Saber Sadiqi, the Department of Mathematics and Science, College of Art and Science, Dhofar University, his presentation on a basics concept of statistics and determination of a sample size. So, Dr. Saber, please start.
And I'm here, yes.
Dr. Zafir.
I was waiting my turn. Oh, Dr. Zafar, if you will remove your screen, then I'll be able to
Dr.
share my
Zafar,
screen,
please,
I think.
if you remove the screen, please.
Dr. Zafar?
Dr. Zafar?
Okay, still you can see the screen?
Yes.
Actually, there is something.
Now my screen is there. My voice is okay,
Yes.
I think.
Yes, all things is okay. Go ahead.
Everything is okay.
Okay.
Now, welcome everyone. This, you are here since morning, and we have listened 4 experts before me. Actually, the topics which we are covering here, they are too much. They need too much time. And because of the time constraints, we are doing something, you can say we are trying to keep the ocean in a bowl. So please bear with us because of the time constraints. My topic was actually, I choose topic to use to discuss the concepts of statistical methods or statistical techniques. And during that discussion, I just wanted to talk about sample size also, but actually that thing is not possible because sample size in itself needs a lot of time. So I concentrated, you can say, I just targeted this issue, okay, just to discuss what is sample size, what we need, why we need a sample. So I will just discuss these issues here. Just some basic definitions which we need to discuss this issue, like population, sample, what we mean by complete enumeration, what we mean by sampling. The population, everybody knows. When we start some research, when we finalize our topic, our problem, then we search where to do. The area where we are going to conduct that research, the complete area, we call it as a population. And from that population, we try to find out the information. And on the basis of those information, we try to analyze the data, those information, and we reach up to a certain decision. This is the procedure. But definitely whole population cannot be considered every time. We do not consider the whole population other than this complete enumeration, or in case of census, we do not go for a complete population. We always go for sample. The sample, it is a subset of population which truly represent the population. This is the main idea behind sample. We need a sample which truly represents the population, It has the all story behind it. How to get a sample which can be replaced by the population and truly what is there. Yani, that sample must reflect the whole population. How to do that? Statistical studies cannot be carried out for whole population always. Census is a special case when sample and population is same. So definitely we need a smaller set that we call sample than the population to save time, to save money and manpower to analyze the population under study. There are many other things also to consider for our study. And if I say in one sentence, that is, we must use all techniques of statistics techniques, measures in their proper form. Proper form means what are the purpose behind that measure. If we miss that idea, we will never reach to a correct decision. We will never reach to a reliable decision. For example, the use of measures of central tendency, measures of dispersion. It's a long discussion, but I'm quickly just giving this idea. And this is the most important idea behind the study. How large should be a sample? How large, what should be the size of a sample? If our size of a sample is not convinced by to whom we are going to present the result, if the body is not convinced, the size, I'm not convinced with your size. Your size should be a little large, or your size is too much, or your size is not okay. In any way, you cannot prove that your study is okay. You cannot say my findings are reliable. Your sample size or your selection of size must be scientific and must follow certain rules laid down by the study, laid down by the subject, so that you can support your sample size. If you can support your sample size, if your sample size has correctly been selected, decided, and your sample observations are correctly being collected, then only your study is reliable. Otherwise, you can say, this is my study, this is my result. You can say anything, but there will always be a lot of questions on your study, whether I should accept, I should not accept. So let us discuss it. We will try to understand what to do, what not to do. I have written some points. Most of you might be knowing. The analysis or conclusive part of the study is based on the data processed for the study. And data or information is coming from the sample. If the information are not reliable, the decision will not be reliable as well. Therefore, we cannot take any number as a sample size. But it needs a mathematical and a scientific approach to determine the size of a sample so that the decision after analysis could not be questioned. So if the size of sample is not convinced, then the conclusion of the study cannot be relied upon. It's a simple thing. So what are the factors which affect the sample size? First of all, the cost. Because every study has a limitation of cost. If your cost is limited, because you will never be having this indication from the government or from anybody for which you are working. Okay, you have unlimited cost. Do it. Not like that. We will always have a cost restriction. For this study, we have this much finances are available, and in that limit, we are not to collect the data. So that is why we have to be very cautious about the size of sample, and we will see how the size of sample is going to affect the cost. So each sample units will cost money. Each sample unit will cost money. Any unit for sample will come, and we will have to spend some money to collect that information, because people are there, surveyor are there, and logistics are there to collect the data. So many things are there. So each sample unit will cost money and time during data collection. For example, if the cost of collecting data from one unit is $10 and the available financial resources are only $100, it's not realistic. The first of the thing is the cost constraint, then the precision, the accuracy level of final result. What accuracy we need, or up to what accuracy we can compromise. Everybody needs 100%. Everybody needs 100%. But 100% is statistics is the only science which says nothing is 100%. You cannot achieve anything 100%. Physics or mathematics says that our calculation gives you 100%. Statistics is the only science which says 100% is the only nature. We are not 100%. Whatever we are going to say, whatever we are going to do will not be 100%. So it needs a level of precision. How much we will be agree if our precision is this much. So that's quantity we need. Then level of significance. This determines the level of confidence. And how much confident we are, we will be having correct data. We may be 95% confident, we may be 95%, or sometimes we may be 99% confident that we will be having this much size and all units we will be able to collect. So the more confident the researcher wants to be, larger sample size, and vice versa. If you want to be less confident, it's okay to have lesser size. But if you want to have more confident, you need a big sample size. Now, estimating the sample size, there are, if you refer the work done by the people in the field, those who are specialized in sampling techniques and in data collection. Basically, there are three techniques. Number one, you can say the crude selection. The crude selection of observations. Okay, we will take 10%. We will take 10%. And this is the only argument. Okay, why your sample size is 150? Okay, I took 10%. This is the answer only. He may agree, the agency for which we are working may agree, may not agree. It depends. Second may be estimation of sample size. Estimation of sample size based on certain rules. When the rules are there, then there is no argument. This is my sample size and I used this rule, and that rule is not given by me. That rule is acceptable by the theory. That rule was was established by using the concepts of theory, by considering the all effects. So when we have this rule and when we are applying this rule, so there is no question of to accept or not to accept. The only thing is, because there are many rules, for which rule we will go. There are the situation. If we have this situation, we will use this rule. If you have that situation, we will use that rule. So what I told, first thing is we will go for just for crude selection based on percentage. Second is the estimation using the rules. And third is also very popular these days. If we don't want to give any trouble to mind, trouble to anything, just go for certain ready-made software and fill up the information, and that software will give you a sample size. And that also convincible. You can convince, I used that software suggested me that sample size. So we are doing it one by one. Estimating the sample size, one of the rule is proportion-based estimation. Proportion-based estimation means, this is the rule, N, any required sample size, Z square, PQ divided by D square. Z is the value of standard normal variable depending upon the level of significance which we are going to bear, which we are going to say. This I'm confident to have this much. The value of Z will depend upon this. If I'm 95% confident to have this value of sample size, the value of Z will be 1.96. If I'm 99%, that value will change. If I'm 90%, that value will change. Then this is P is here. P is the proportion of probability in the target population to have a particular characteristic. Whenever we go for choosing a sample, definitely there is a problem. There is a problem in hand. For that problem, we are going to select a sample. What is the probability in the population to have that characteristic in the unit? That probability is known as P. Sometimes we have, sometimes we may not have. Sometimes we may have, this is the P for which we are going to find out the population. So this is the P. Suppose we are working for people who are using four-wheel vehicle. And we are going to study what is the rate, or how many people, or what is the percentage among the people in a certain city who is taking car through bank. So we can find a probability that around 80% people take car from bank, through bank. So this P is 0.80 and Q is 0.02. But if this information is not known, then P usually it is taken as 0.5. When P is 0.5, Q is obviously 0.5 because P and Q have the same relationship which was initially given by Bernoulli. The P plus Q is always 1 in the same population. So this P and Q have a very strong relationship. Wherever statistics is going, whosoever is working on it, P plus Q is always 1. That relationship is not breaking even. Then this D. This D depends upon the user. And if I talk in terms of in a professional way, user is not independent. User or data analyst is not independent. His job is not independent. His job depends upon the requirement to whom somebody is asking. It is between me and my partner. Okay, how much error you can tolerate? If my decision is wrong, so would you go for suicide, or you can, adjust something? This is the tolerable error. If tolerable error is 5%, okay, its value will be 0.05. If tolerable error is 10%, its value will be 0.90, like this. So we decide these types of error in this way. If I use this, I just calculated one example. If the population proportion is 0.60, it is known to us. If desired accuracy is expected to be 95%, that is the expectable error is 5%. And if the confidence level is also 95%, this is by chance. This is by chance. I am talking about confidence level also 95%. And expected accuracy, I am expecting also 95%. Or you can say the acceptable error. Acceptable error means that much error I can accept. More than this error, I cannot accept, like this. So here the value of Z, as I told, it will be 1.96. P and Q will be accordingly 0.64. Then 1 minus 0.64, yani 36. And D is 0.05 square. If you calculate, we get 354. For that population, the sample size should be 354. Okay. If you change something here.
Could you please, Dr. Saber, summarize your presentation, please? The time. Could you please summarize the time, please? Yes. Try to summarize. Try to summarize your presentation, please.
Okay. I'm not.
Thanks a lot. Thanks a lot.
Okay. Okay. Just I have shown these two examples for that. You can just check. If we change the value of Z, P, Q, D, we will get the change. We will get the changed number for sample size. Okay. And here, this example for me is an important one. If desired accuracy is expected 90%, but I'm confident 95%. So these values will change. This example 3 actually especially is to show that in fact there is no relationship between Z and D. Z and D, these are both, like there is no relationship between Z and P also. But these two terms, when we speak out, it looks similar. That is why there may be confusion. So there no need to be confused. And this another method, variance-based estimation. For that variance-based estimation, we also have this rule. And this rule is used when variance is known. If we know the variance of the data, then we will use this rule. Okay, Z square multiplied sigma square over D square. Z square has the same meaning. D has the same meaning. So with the same meaning, we can calculate here these type of values. I have calculated for these information. If standard deviation is 4.5 and D is 0.05, then see the size, 38,416. So if you don't want to compromise with the accuracy, so you need a big sample size. If you are okay, I can bear with the 10%. That's immediately it reduced to 3,000. So this is the, I mean, you can see the importance of this D. Okay. Dr. Musallam is saying stop. So I am stopping here. If population size is known before 10,000, and now the sample size has determined lesser size.
Dr. Saber, go ahead. You have 5 minutes. Go ahead.
Okay,
go ahead.
Okay. Thank you.
Just to inform you about the time.
Before I was having a sample of size N for when sample size was 10,000. Now my population size was 10,000. Now my population has reduced to 1,000. Then what will be the new sample? What should be the new sample? So this rule will work for that. How it works? When it was more than 10,000, the sample size was 500. Now it is reduced to 1,000. So the sample size will be calculated by this 333. Okay. We were discussing actually these things. If we use these mathematical techniques for our sample selection, and if we use our appropriate measures, if population median, if measure median is to be used, we are using median. If arithmetic mean is to be used, we are using arithmetic mean. It looks very easy and simple. They are simple measures, but they are not so simple. There is a lot of discussion in between where to use arithmetic mean, where to use geometric mean, where to use harmonic mean and median and mode, and where we should go for moving averages, where we should go for quadratic averages. It needs a lot of information. Anyway, if we are using everything properly, nobody can challenge your work. Otherwise, there is a very important, famous phrase for statistics. I have just finished by using that phrase. That was I was just searching. It was used 100 years before. Just by following the concepts and techniques of statistics in proper way, we can save our findings from a very common phrase, which is quoted as, there are 3 types of lies. One is simple lies, then dumb lies, and statistics. If my work is not supported by these techniques, it is difficult to trust. It is difficult to trust your work, whatever we have done. So please avoid this phrase. Keep our research work away from this phrase and do our work accordingly by using proper techniques, by using proper measures. There are a lot of literature available now. No need to just blindly follow any software. Use proper technique, proper literature, and use proper techniques, and avoid this phrase so nobody can challenge you. Your work is not trustable. So this is all for this is a short session. So thank you for your patience, and thank you very much. And Musallam, now over to you. Please invite the next one.
Thanks a lot, Dr. Saber. Thanks a lot for the nice presentation and the nice information. So this symposium will deal with a time series analysis. So let us now invite Dr. Khaliquzzaman Khan, School of Business, American University in Dubai. His paper or his presentation on time series analysis. So please, Dr. Khaliquzzaman, start your presentation. Time with you. Dr. Khaliquzzaman Khan.
क्या है नहीं कहाँ चले गए?
No, I am here.
Okay, just we want to hear your voice.
Can you hear me now?
Yes.
Yes, yes.
Yes, yes, yes. Go ahead, doctor.
Yes,
Can I
that,
share
I'm
the, yeah, share the slide, please? Yeah, 1 minute. Can you see my slides, please? Can you confirm?
Yes, we can see.
Yeah, and do you hear me also?
Yes, we
Okay,
can hear
fine.
you.
Yes, go ahead. Go ahead.
Thank you so much for inviting me for such a wonderful session. I feel very happy to discuss the topics on statistics, especially the application side. But more than that, I feel more happy that I see many of my friends because, as you know, I had a very long association with our university and College of Business Administration there. Perhaps I was the one of the pioneers of the university. Not perhaps, sure. So I feel very happy and proud to be with you all again, especially my Dr. Siddiqui and Musallam as a moderator. I will take not much of your time just to discuss about the time series analysis using SPSS. Before I go ahead, I just want to say that the older name of SPSS was a Statistical Package for Social Sciences, and it is no more. Since it is taken over by IBM, its new name is Statistical Product and Service Solutions. So anyhow, it is the same thing in a different with a different name. So here, if I increase. Time series, actually, it is actually there are two types of data. All these colleagues and students might be will be are well aware that cross-section data and time series data. And time series data is related with the time with the set of interval. And so the time series is a set of observations on the values of variable taken at different and regular time frame, not haphazard, meaning that weekly, daily, monthly, quarterly, yearly. So and we use this time series for forecasting. The purpose of time series analysis is for the forecasting. There are other methods of forecasting also. One of the most widely used is the regression analysis. So what is the difference between here? As you see on the screen, there is an equation y is equal to a plus bx. That is the linear equation, simple regression. Here, there are two variables. One is independent, that is denoted by x, and the other one is dependent y. So y values depends on x. But on many cases, this independent variable is not available. Only we have the values of some variable. So what to do? We cannot use in this case the regression analysis. So in this case, often we have only y, or we do not know other values of related variables with y. So study the time series analysis is required. 1 minute, please. Give me 1 second. Okay. So this one, the components of time series. I will just take the brief introduction of time series, then I will come to my problem. What I have done is that I have taken a very practical use of this one, and because most of my audiences are from Oman, so I have taken the real data, bayanat haqiqi, not majazi, from Muscat security market. Initially, I considered, I think, 5 or 6 but now I reduced to only companies, companies which are registered in Muscat security market. But before coming to that, just refresh your memory about the time series. So time series has these following components. One, the most important, one of the most important is the trend, the long-term relative smooth pattern that usually persists for more than 1 year. However, it is the trend is moving up or the trend is moving down. If hope you can see me, because and another one is just seasonal. As the sound it says Mosami, Mosam. So it is the pattern that appears in a regular interval, wherein the frequency of occurrences is within a year, but maybe the shorter, but not more than a year. Means it can be monthly, it can be weekly, it can be even the 24 hours. Sometimes, certain rush, like I am in Dubai, from Sharjah to Dubai, morning rush is high, and then the rush next time. So it is seasonal or quarterly. Cyclical is that the repeated pattern that appears in time series but beyond a frequency of 1 year. Cycle like this is there is a recessionary cycle. It is moving up and then it will come the another way. And then after maybe 10 years, 5 years, it will come again. And as the example is written here, economic recession or inflation like that. So next, yeah. And then another one is that random, that component of time series that is obtained after these three patterns have been extracted out of this series in a random component means that does not have any pattern, as the name it says. I'll show you. White noise. The series is called white noise if it is purely random in nature, mean and variance. 1 minute. Okay, I will correct it. Mean of variation is 0 and its variance is constant. Means it is hovering on certain line. So it is the plus and minus, so it is 0. But the variance is also constant. Sometimes it is hovering, but initially it is small and then it is going up. So the variance is increasing. So it is not like that. The variation is the constant. So this is called white noise. And the time series models, the popular models are moving average model, MA, commonly known. We used to teach this model to undergraduate students. Autoregressive. Autoregressive means autoregression. That is one in which the variable depends on its past variable. Maybe the 1, 2, 3, depending on what. So it is the function of its past variable as it is shown here. It can be date past before before one period, another one period, like this, it is up to that. So if it is, and if this part is 0, then it is not, it is just constant, that is beta 0. And then another one is moving average model. There is another one which is mixture of this one, autoregressive moving average, ARMA. Those who are in this aware of this one, they know ARMA and ARIMA. ARMA is the autoregressive moving average model. It is a combination of both. Yani it is, you are regressing it to the previous one as well as you are also using the moving average model. And there are three very complicated equations for each one of them. That is not the scope of my discussion today. So another one is auto-regressive integrated moving average model, which is also very commonly known as ARIMA. And there is another one also, S-ARIMA, that is seasonal. But ARIMA is only that it is the combination, in addition these two, plus integrated. Integrated means that you say that you will not take the absolute value of the data, but you will take the difference of that. You take the difference, and one the previous one minus the next one, like that one. So you will take the difference. When we use this one, so this is called ARIMA model. Error, trend, and seasonality. These three terms are main components of the time series. The smoothing method calculation, we take errors, trend, and seasonality. I just discussed 2 slides before. Either add or completely ignore. Add or multiply or ignore. We can determine if we need to add or multiply ETS by looking at the time series plot. This plot will split the data into seasonal, trend, and error. Additive model, commonly known, and multiplicative model. How we do it? Just additive model is that we do this approach is we used when the trend and seasonality pattern is relatively constant over the time. The picture is in the next slide. You can see it. And multiplicative is approach is used when the trend and seasonal variation increase or decrease in magnitude over the time. In magnitude, in multiplication. It is easier to spot a trend graph. Additive trend will show a linear behavior, whereas multiplicative trend show the exponential behavior. Constant variation seasonal pattern is constant variation, means variation is there, but it is not increasing or decreasing. It is in the seasonal pattern, then it is additive. But when that increase variation in seasonal pattern is when there is an increase in variation, then we use it multiplicative. Like this one here, you see it is moving, but the seasonal variation is the same. So this is the magnitude of this one, and this fluctuates trend, and this is the additive. But here you see it is variation is there, but it is the magnitude is increasing, so it is a multiplicative time series. This matrix type figure will tell you that this is the additive trend and seasonality. Seasonality also like this one here, and it is not moving, increasing, and it is so it is the trend is almost a straight line, so it is additive. And here, uh, 1 minute, multiplicative seasonality is multiplicative if how? See here is small and then it is increasing, but the variance, this one, so this is called multiplicative. And here, uh, here you see that the trend is going up, however, the seasonality is not changing. So this is the multiplicative and additive, and here both of them are multiplicative and additive. Seasonality is also multiplicative, as you see it is increasing. Trend, it is see going up, not a straight line. So it is also, it is both of, it is case of multiplicative trend and multiplicative seasonality. Why I am showing you this thing is that when we have, this is the theoretical part, when we have real data, and we plot the graph, we will be puzzled which model should we use. We can use different models, then calculate MAD, yani mean absolute deviation, and other criteria to find out which one is the best. Another one is that my other friends who are using time series exponential smoothing, that is also used in seasonality when there is a seasonality. So which alpha should we take? Should we take 2, 0.2 or 0.25, 0.23, 0.5? Which one should we take? And then find the best one. It was a hell of job. Now I have taken the example of real data from 3 companies from Muscat security market, and we try to explain you how we can use time series without having a big hassle of all those. Just for the sake of example, I have put here, shown you quarterly sales Al Anwar ceramic, and the source is, as I told you, Muscat security market. These sales I have taken it all these years. from their financial reports. So I have taken for the three companies, Al Anwar Ceramic, Oman Cement, and Resut Cement. But for the sake of example, I just put this one for you here for only one. Now, this is the sales, quarterly sales. This is the 2007 till 2020, third quarter. Fourth quarter is yet to come. And this is the graph of this sales. It is going up and it is going down, then perhaps it is again going up. Which model should we use? Moving average, exponential smoothing, ARMA, ARIMA, which one? There are many others. So this is the question. This is the Resut cement. Same thing, same. I didn't put the data. It is with me. Just like this one data here. Same thing, Resut. And same thing for Oman cement. Now, which one should we use? Don't worry, I am going to show you, and especially my researcher colleagues and students, you will appreciate this thing, and I will take you to the Excel file, SPSS file. I opened this one. I do not know how it got closed. Okay, it is here, and we import the data from there, and I just put it here. Oman, which one is that first? 1 minute. Oman cement, this one. OMCEM. Oman cement. This
Your
is.
PowerPoint is sharing, not your SPSS.
Oh, sure. Here I go here. Where to go this one? How I go back to, yeah, stop sharing here. Then here. Okay, this one is now Resut cement. Al Anwar ceramic. Okay, fine. I will bring the data from there. Oman cement. Oman, Al Anwar, and Resut. Okay. Here. Sorry, Excel sheet you may not be able to see. I'm just copying and bringing the data here, and that's all. So this one is, this is the data. Now it needs date, because there you know that I put the quarter one, quarter two, and years. And the year is started from, this one is started from 2007 quarter one. Fine, so I will go here. Please see this one, you go here, you come here. Go to data. Here, please listen carefully. Define data and time, and this is define data from data. Since I did not put in SPSS data any column, so So I will start from here, data, this one, and it is year and quarters. See here, years and quarters. Year is starting from 2007 and quarter 1, 4 quarters. So here I click OK and it should come. See here, year, quarter, and this is the date. Quarter 1, 7, 2, 3, then here, and it will come to quarter 3 of 2020. Now our data is ready to go ahead. I will not take more than 5 or 10 minutes. So because other speakers would also be waiting. So I will go to analyze, go to forecasting, and go to sequence chart, and we take these 3 data of Oman Cement, Al Anwar, and Resud, and here this one we take it here. Remember, this date is a nominal data, and if you do not select this one down, it will give the graph all in one slide. So better to have separate. So put it here and then here. See here, this one 0, this no missing. So here it is the same graph as you see in the Excel. Where are others? Yeah, it is here. It is the same graph in SPSS. Display format is little different than SPSS. Now we go to analyze, forecasting, and forecasting, and create, analyze, forecasting, create traditional model. This is SPSS 221. So here we will select these 2, 3. Here we don't have independent and we do not want to link, and there is no independent variable. Leave it. This is the one which I am talking about. This is the thrust or gist of my discussion. Expert modeler. Otherwise, you can use exponential smoothing or ARIMA. In ARIMA, as you know, auto-regressive model is there, integrated is there, moving average is there. Have to put your values. You want to take it auto-regressive with 1 lakh, 2 lakhs, 3 lakhs, like this. Moving average also you have to give for how many. And in auto moving average also you will give exponential also, it is here exponential smoothing, then you have to give alpha. And then out of so many methods, you have to select the one which is the best estimator, which estimates the best. So here, leave that one. This is the beauty of SPSS. It says that you take rest, SPSS will do all the job. This SPSS, this function will select the best among the possible methods available. So you select here and then go to statistics, keep this one as it is. In next lecture, we can talk about these values there, goodness of fit, plot, observed value, and forecast value. And then output filler include all models in the output. If you put it here, then you will select and give. But here, leave it to SPSS, it will include all models and give you the best one. Save, predicted value, this lower control limit, upper control limit, and you have to save this. Suppose, what is this presentation? Presentation. Today is 30 December. Okay, I will save this thing, not in the document. I have my drive here. is here. So I will save it. Good. Option. Yes. Now, which for how many years you want to make it forecast? Remember, my data was third quarter of 2020. Fourth quarter is coming, and suppose you want to make it next year also. So here you will write 2021 and up to what quarter? Up to suppose 4 quarter, the whole year. It is up to you, you can give it. Then Badahu, okay, after this, you go here. See here, before I come to this one here, see, this is the for Oman cement. Up to here, it is the 3 quarter. It is written here 3 quarter. If you see down here, and up to here, and this is the quarter 4 and 4 quarters of next year. So that is the quarter 3, 1, 2, and 3. This is this one, and this is the one which is used this one here. If you want to see it, but before that, I will take you to here. Oh, I forgot to select one thing, gentlemen. Just 1 minute, please. Forecast, create this traditional. This one plot, no statistics. Yeah, I forgot to use this one. Display forecast. So anyhow, we will do it again. This is done. Here, this is the display forecast. Oman Cement, quarter 4 of 2020. This is the forecast, and this is the upper limit. This is the lower limit. Same as Al Anwar. This is the forecast, upper control limit, lower control limit. By the way, when I already finished this one, I thought I should have taken the stock, share price, but it was too late. This can be expert modular, should be used very well for the estimating the share price for investment. So here, this is this one here. This is the graph, and this is the forecasted value. This is linked with this one here. If this one is not easily, you do not happy. Okay, go ahead. Go forecasting. Create additional model and plot. Do not put the observe. Leave the only forecast. So see, this is the only the forecasted. You can see it here. Quarter 4 2020, quarter 1 2021 up to quarter 4. Sorry. My throat is Kharban. So this is forecasted graph. I will talk more about. This is the table which we are interested. I told you this thing. I will discuss you, Dr. Musallam. If you how much?
Khalil,
how many minutes do I have?
Time is over. So please, if you summarize.
Yes, summarize. Just 2 minutes remaining.
Summarize, please, and quick.
Sure. Thank you, Musallam.
Thanks a lot.
And my dear colleagues and listeners, see here, this system is telling you that for Oman Cement, it selected simple seasonal. And Al Anwar also winter multiplicative, Halt's model and winter. So this is using for Al Anwar winter, and for Resooth simple. It has done all the work for you. The last point which I want to show you here, go to data and see here. For each one, it has given predicted value, lower confidence level, limit, sorry, not confidence, control limit, upper. For each one of them. This is Al Anwar, this is model. Now, if you want to draw the graph, you can easily draw the graph, select these ones, and go to graph, chart modular, okay, line, this is multiple more than one, bring it here, very good, date is the x-axis, bring it here, and then here this one bring here, and it is okay. If you want to make it something like a title and footnote, you can do it because the time is short. So I will leave it here, and then this one I should remove this one from here, and okay. Thank you, Mr. SPSS. I can expand it. And you can change the color. You see here, this is the middle line is the predicted value of Oman cement, and this is the upper limit, which is very dull. I do not know. I can change the color, but the time is short. Let me just do 1 minute. This one, if I can do it. This one here. Oh, very good. Suitable? Yes. Now you see this, instead of changing each line color, I change the background color. It just occurred to me. So this blue color is the line which is predicted for the this one from this till 2024 quarter 4, and this one is the upper limit and the green one is the lower one. So in this way, we can do a very good prediction without bothering which model should be used. So this will be helpful to especially the investors in the stock market. If next time anybody wishes, I can do it for the stock market prices and share prices. This concludes my conclusion. I hope that Mr. Musallam, I am within the time.
Thanks a lot. Thanks a lot. Thanks a lot, Dr. Khalil Zaman.
Yeah, I was your colleague.
And thanks.
Zaman Qadim.
Thanks for a nice presentation and a nice information. So now we invite Prof. Muhammad Asif Gundal. He wants to discuss about something. So just, Dr. Start, Prof.
Okay, thank you, Dr. Musallam. So I just only want to share that I already uploaded the link. If you see in the chat box, link is given to access the certificate of participation. So you can go there and you can fill the form, and the certificate of participation will come in your email. Okay, so only I want to announce this. So you can fill that form and you can get the certificate for participation. So I also updated that in YouTube and plus here in Zoom. Thank you very much.
Thanks a lot, Prof. Muhammad. So now all of us, we know the importance of to choose or to select the journal for publication. So let us to invite Dr. Sharida Dividi, Department of Mathematics and IT, University of Technology and Applied Science, to present her work on selecting of a journal for publication, impact factor, H indexed, and so on. So, Doctor, please start the mic with you.
Thank you, Mr. Musallam. Thank you. Welcome, everyone. Good afternoon. Before I start my session, I would like to pay my sincere gratitude to Sir Dr. Asif Gondal, head of the department. And I would like to extend my gratitude to my mentor, my guide, and my co-author, Dr. Sabir Ali Siddiqui. Thank you so much, sir, for this webinar. So welcome once again, all esteemed participants. It is a discussion on some research-related topics like selection of journal for publication, impact factor, H index, JCR and SGR, ORCID numbers, and predatory journals. So broadly, I have one moment, please. Broadly, I have divided my presentation in 3 parts. First part, we will discuss about impact factor, how it is get calculated, what is JCR and SGR, what is H-index, and what are the online tools and engines to check impact factor and H-index. And second part, we'll see how we can select a good journal for a publication, what are the online tools for this, and what is an ORCID number and how it is useful for us. In the last and the third part, yes, please. In the last and the third part, yes, sir. Am I audible, sir?
Go ahead, no problem, go ahead.
Yeah, okay. Thank you. So the last and the third part will be discussion on predatory journals. We will see that why we should not publish in these predatory journals. So first we'll start with the impact factor. In layman's language, we are saying that impact factor is a measure of the importance of a journal. Yes, we all know, but technically it's a metric that can give you an approximate idea about how prestigious a particular journal in its field. In its field means in a particular subject area only, because like if a journal is concerned with the medical field, its impact factor can be very high, but you cannot compare that journal with a journal in mathematics field or a statistic field or IT field. So in particular field, its impact factor can be high. And then it is used to compare journals. It is used to compare journal in similar subject categories. So higher is the impact factor, higher is the ranking of the journal. So these are the importance of impact factor, and it also reflects the size and the age of the journal, because if the size of the journal because if impact factor is high, that means size of the journal is also high, and journal is old also, because it is known by more and more researchers and scholars. So more citations are there means impact factor is high. Now, who gave the concept of impact factor first? So it was given by Thomson Reuters. This is a Canadian-based company, so we'll not go in much more detail about that. So they introduced general citation reports. So basically, they started this general citation report for biological journal to check the recency of research. And the first JCR report was published in 1975 by Clarivate Analytics, which is a group of Web of Sciences. We all know that ISI indexing for Web of Sciences group. So they published the first JCR report. This report is actually, we will see in detail JCR, how initially they started biological journals, but now they cover almost all fields, life sciences, IT, business, all fields. So we'll see JCR in little detail. So JCR, or General Citation Reports, is a product of ISI Web of Sciences group, and it is an authoritative source for impact factor data. So if you want to check the impact factor for any journal which is indexed, which is in the database of Web of Sciences, you can check JCR report. We'll see this live also. I'll show you one website here where we can check this also. So basically, JCR can show you the most frequently cited journal in the field, highest impact factor journals in the field, and it will provide you the ranking of the journal also, so you can compare the journals. Where you want to go for publication of your article, you can check, is that journal is good or not, what is its impact factor, that and all you can check. But it has some limitation, that it is limited to the database of only Web of Sciences group, and it indexes over 12,000 journals in all subject areas: arts, humanities, science, and social sciences. So the question is here, if the JCR is giving limited for only Web of Sciences, so where is the report which will provide us the detail of Scopus Index General? So there is a list, there is a report that is known as SJR. Its full name is Chicago General and Country Ranking. It will give you the country ranking also on the basis of the research work, and this is a product of Elsewhere Group, and they will provide the impact factor details and many more indicators for the journals, those who are in the database of Scopus. So mainly they are using two indicators, SJR and SNIP. Chicago General Rank and Source Normalized Impact Factor. We will see, we will not go in detail of these these details of these indicators because time is limited, but we will see how they are, what indicators they are providing, we'll see. And this report actually contains more than 15,000 journals from over 4,000 international publishers, as well as over 1,000 open access journals. So this is all about JCR and SGR. Now, how impact factor getting calculated by JCR, SGR, or DOAJ index? I'm not using other indexes. DOAJ index is also another important thing. Data of open access journals. So mainly I'm taking JCR and SGR only. So how they calculate impact factor? So there is a generalized rule to calculate impact factor. It's a ratio of citation window and publication window. Please note down, I'm using this word window. Window means a particular slot of time. So the number of citations in a particular slot of time to the total number of publication in a particular slot of time. Now, what is this particular slot of time? This is in general is taken as by all reports. In general, they are giving for 2 years. So if you want to check the impact factor for the current year, like for 2020, if you want to check, you have to check the number of citations for 2 previous years, like 2018 and 19. So in mathematical form, it is here. So the rule is first a numerator. If you want to, suppose I have taken example for 2019 because 2020 impact factor data is nowhere available till now, whatever till now I have seen, and even for 2019 also. In some sites it is available. So if you want to check impact factor for 2 years, for year 2019, so you have to check total number of citations to the articles published in 2 previous years, 2017 and 18. That will be the numerator, and denominator will be total number of articles published in the similar 2 previous year, 2017 and 18. So divide A by B, you will get the impact factor for year 2019. Just for an example, I have taken some numbers over here. Like articles published in 2017 and 18 in year 1. So number of articles published in year 1, 2017 are 30. And in year 2, the number of articles published are 40. So total 70 articles published in this slot in 2 years time, in this window, you can say. So, and total citations received by these published articles are 140. So impact factor will be the ratio of total number of citations to the total number of publication. In that case, impact factor is 2 over here. So this is how we can calculate the impact factor, and JCR and SGR, they calculate, and other indexes also. The rule is generalized one. Now, JCR reports and SGR reports, they also calculate the impact factor for 5 years also, but mostly and commonly they calculate for 2 years. But if you see for 5 years, the rule is same. You have to check citations in 2019 to the articles published in 5 previous year from 2013 to 2018 to the articles published in the same 5 years period, 2013 to 2018. So that will give you the 5 years impact factor. So rule is same. Now, one more important thing I want to mention over here, that JCR reports also calculate impact factor without self-citation, because there are 2 ways, outside citation and self-citation. Every scholar and every researcher, they do self-citation, but JCR reports also reflect impact factor without self-citation. So you can compare the journals, in which journal without self-citation from outside citation is more. So you can compare journals on the basis of this. Now, what are the additional points, those who are connected with the impact factor, or those are reflected by impact factor? There are certain things I want to mention over here. Like first is subject variation. As I said that impact factor, if you will go for impact factor for medical field, biological field, impact factor will be very high. 80, 88, like that. We will see live on, I'll show one link. So impact factor is very high, but if you will come to mathematics and statistics, like mathematics is my subject. And so if impact factor will be, maybe if it is less than 1, it is a good general. You cannot say that general is not good, because it varies from subject to subject. In medical field, every day there is a new research. But if you go for a mathematical field or any statistical field or any other subject area, even on you go for business also, that much research is not there. But for this medical field, research is too much. So that's why impact factor is very high. So it varies from subject to subject. Now the question may arise, why 2 years impact factor? So I said this before also, that they wanted to check the recency of the research. That's why they have taken 2 years impact factor in general. Now another question is every published item counted? Yes. If the journal you are going for publication is in the database of JCR, is in the database of Web of Sciences, in the database of Scopus, in the database of DOAJ, and there are many more indexes are there. If they are in the database of all reputed indexes, yes, it is counted. Your research work is counted for the calculation of impact factor. But if your work is published in predatory journals, so that work is not counted. So predatory journals, definitely we will discuss in the last part. And the fourth thing is review articles, how it is connected to impact factor. So we will understand what are review articles first. So review articles are basically articles, those who surveys and summarize the previously published studies. They will not give any new facts or new analysis, new data. They will just summarize the previously published studies, and sometimes they are called survey articles also. And they will provide you the detail of the main people working in that field for particular topic or for particular subject area. Main people are those who are working in the field. What are the advanced discoveries in that field? What are the significant gaps in the research? What are the current debates are going on, or where the research might go next? So these informations are very important for a person who's willing and wishing to work on a particular topic. So review article gives you all these informations. And academic publishers, those who are publishing these kind of articles, they are called review journals. But my question, or someone may ask that why I'm discussing with this, because if review articles, person will quote many people's name, their work, so definitely citations will be more. If citation will be more, it will be reflected in impact factor. Impact factor will be high for a particular journal. This is the reason nowadays most of the journals, they are supporting review articles, and you can get easy access for means easy publication also for review articles. So this is all about impact factor. So impact factor is basically, as I said, it is a general metric, general related metric, but there is one metric which is related to author level. So this will provide you the detail of author, if the author's productivity and site impact. So this index was suggested in 2005 by John E. Hirsch, and sometimes it is called Hirsch number or Hirsch index also. So as I said, this is an author level metric, and it measures both productivity and citation impact. So these both should be same. Productivity means number of articles published and number of citations received. Minimum number of citations received. We'll see this in this graph and with this example. So on x-axis, number of papers are given here. On y-axis, number of citations are given here. If you notice, the number of publication is equal to number of citations. How it can be defined, we can see here with this simple example. Like one researcher has 5 publications, A, B, C, D, E. So every publication, every article has received these many citations, 10, 8, 5, 4, and 3. And its H index is 4. Why? The reason is, if you notice the total number of publications, those who are having equal to 4 or more than 4, equal to 4 or more than 4 citations are only 4. You can see this is more than 4, more than 4, more than 4, equal to 4. But if you check this, this is not. Someone may ask here why it is not 3. So yes, it can be, all the numbers are more than 3, it can be 3, but look at this, the number of publication. All 5 publications have more than 3. So number of publications are 5 and number of citations you are taking more than 3. So this is not equal. If you check 5, yes, citations can be equal to 5 or more than 5, but other 2 journals have less than 5. And total number of 5 publications, which is having equal to 5 or more than 5, is not there. So 4 is the best suited number. So number of publication are 4 and number of citations equal to or more than 4 are also 4. So that's the reason H index is 4. I'll quote one simple example over here, like one researcher has only 2 publications. First publication received maybe 10 citations, another publication received maybe 15 citations. So in that case, his H index will be only and only 2. Why? Because his publications are only 2. So as I will come back to this graph. So number of publication should be equal to minimum number of citations. That's the reason H index can be taken like this. So I'll move on. Now question is where to check impact factor in H index. There are certain websites, certain websites are there, like researchify.com, Shimago for STR, Thomson Reuters, JCR, Web of Science Group. So I think I have already opened these websites. I'll check here. 1 moment. Yeah, this is for Researchify. So this is the home for Researchify, like this. So you can check other details over here. But right now we are checking for general ranking or impact factor. So we'll go back to this. And I'll take in general of statistics. So whatever are the generals available over here, it will give you the detail. And if you want to go for particular general, like impact factor, they are giving here, impact factor for these generals. Now, if you want to check their archives also, it is available. Their H index is 44. This is a pretty much good number for H index. Impact factor 0.57. Other details, year impact factor. For the previous years also it is given here. You can see the graph. Impact analysis is also given here. Comparison of impact index for last 2 years. Percentage of change. For last 5 years, average. Highest value was in 0.85 in the year 2016, lowest value in 2017. If I want to check for any particular general, like I check this one. Yeah. So Oleg General of Science and Technology. So you can see its H index is this, its impact factor is 0.41. Similar way you can find for particular general like this. Now we'll go and check SJR. So SJR, please ignore this. So general ranking, this is the home page. You can choose your subject area and first page is coming like this. Like as I said, for medical journals, impact factor goes very high. You can see this 88.
Dr.
They are
Sharda,
using
please.
other.
Dr.
Yeah?
Sharda, please, if you quick, please, the time.
Yeah, yes, sir. Okay, sir.
Time,
yeah.
please. Okay.
Yes, sir. Yes, sir. Yes, sure, sir. So these are the indicators you can use, and I will mention only this Q1, Q2. So generals mainly they fall in 4 categories. Topmost in quartile 1, and second 50% category in quartile 2 and quartile 3, and then quartile 4. So if you want to check particularly for any general, you can see in which category it is fall. If the general you are going for falls in Q1 category, that's like an achievement if your paper get published in that. So this other JCR I will not discuss. Link I have already given. One can check because time constraints are there. Now, for selection of generals, what are the points we usually keep in mind? Indexing preferences, what our workplace research committee is asking, which kind of indexing they're asking, and then prepare a list of available generals, determine the impact factor. These are common things we always check. And then you can check the business model, whether it is open access or subscription type. And then you can check, previously published articles also. that will give you an idea to reframe and rewrite your general, and so that you may fall in the category of acceptance range, not in the rejection range. These are the general finder tools. Quickly, I will show these general finder rules. So I'm not able to access actually. Why these tabs are coming to me? Yes. So here, these are the general finder rules for elsewhere. I have taken for Springer, I have taken for Wiley, I have taken for IEEE. You can check this link. If you paste abstract over here, like for example, I'll paste. So find generals. So yeah, it will show you all the generals like impact factor, acceptance rate, time of first decision, time to publication. You can check what is your criteria. You want high acceptance rate, you want high impact factor, or you want to get a quick publication. Accordingly, you can decide. So I'm not going to all details. The links are here. And then the last I will take ORCID number. ORCID number is a digital identifier which is connecting research and researchers. How? When you sign in for ORCID number, you will get a unique digital number like this, which will work as an ID that will distinguish you from every researcher with the same or similar name to you. And now why I'm mentioning it here, the reason is whenever you are going for a good general, then every time you have to sign up with those generals, and that takes a lot of time. That is sometimes very time consuming and tedious also. So but if you have an ORCID number, you can directly sign in with this, with the help of this. So the general you are applying, they will extract your data. That is safe only. They will extract your data from there, all details. So this is the use of ORCID number. It will simply save your time. And now I will come back to predatory generals. So predatory generals are mainly fraudulent kind of generals. So before we go, I will just summarize this academic publishing. It's here, so time constraints, so I'll not go much for this. Just broadly, it is divided into general and self-archiving. People, those who are going for general publishing, it can be of open access. But if you are going for open access, that means you have to pay a little more fee for that. It can be of subscription type, and it can be of both type, hybrid type. If some due to some reason, if researcher cannot go for publication, they can go for self-archiving. Researchgate.net is there, Academia.edu is there. Mostly in medical field and education field, people go for this. And some subject repositories are there. More detail we cannot say, but there is one nature.com where you can find these subject repositories. So predatory generals are of three kinds. One is publisher kind, those who will publish in all subject field. Standalone, they will be a single general. They will appear for a limited number, limited time only. After that, they will elope. You will not find their archiving. Hijack are some publisher, those who have having strong money backup. They will pay a handsome amount of money to the reputed generals, and they will take their subscription for some they will publish their work with those generals, in collaboration with those generals, for a certain period of time. But later, if you will check after the end of the subscription, no archiving will be there. So these are called hijack generals. Now, how you can understand what are predatory generals? So you will get emails for the publication for these predatory generals. They will give you direct link instead of any author's guideline, anything. Directly they will ask to give you the link to submit your manuscript, and that manuscript will be accepted accepted within 24 hours or 2-3 days only. So in that case, they are not performing any peer review work. They are not doing any plagiarism check, or for just for the sake of show off, they will fill some forms. They will have a fake editorial board. They will take some good names from the internet. They will paste in their editorial board. So researchers or beginners, they will get wooed by this. So they will have no legitimate contact information. They will show false impact factor claims. They will mimic some reputed generals. They will put some similar names, so people get confused, and they will
Dr.
go
Sharda,
for those
please.
generals.
Dr. Sharda,
Yes,
please.
sir. So shall I conclude here, sir? Yes, sir. Can I conclude, sir?
Conclude. Yes, conclude,
yes, sir.
please.
Yeah. Okay, sir. So
Shraddha, quickly finish quickly.
Yes, sir. But only one slide left, sir.
What's it?
Okay, sir. So acceptance rates will always high. 100% acceptance rate will be there. Then why we should not publish in predatory journals? Because it does not count. They have only business model for making money, and they will have no contribution in the research field. So you should not publish in that because it will not count.
Please, doctor.
It is just
please,
a loss
doctor,
of
can
time.
you share? Can you share your slide?
Yes, sir. Okay, sir. I will conclude here, sir. Thank you, sir.
Yes, and share your slide, please.
Yeah, sure.
The slides are not visible. It is visible.
Sir, I have just only one slide. This is the last slide. If I can share, otherwise I will conclude, sir.
Okay, no problem. Go on.
Yeah.
Continue.
Okay. Thank you. So this is just a loss of time and money, because there is for this there is no contribution in research field, and somehow directly or indirectly, if you are getting you are publishing your work with these predatory journals, you are helping an illegitimate business, because these people are in unethical services. So you should not support them, and it will have a negative impact on your career, because if your work is published in predatory journals, you are applying somewhere it is in your research database. So sometimes if they come to know that it is in predatory journals, it will have a negative impact on your career also. So better to be zero than negative. There is a checklist where you can see the Bell's list. Bell's list is there where you can check all the predatory journals, check indexing, archives, ranking of journals, peer review, editorial board, and affiliations. And if you have already published in predatory journals, you can just remove it from your database, because it is. Yes, sir.
Why people are complaining there? Your slides are not visible there.
Not
visible
visible
to me. Why not? It is visible to everyone. What is that?
I don't know, sir.
Huh?
From my side, everything is going fine.
Yeah,
okay,
try to share your slides.
If there is anything.
One more. I will try it again, sir.
Okay.
Okay, no problem. Okay, go ahead.
Can you see now, sir?
You share again. You share again.
Yeah, I did. I see it. So I did so, sir.
See the checkbox.
Resume share. Okay.
Participants.
Okay.
Is it
okay now?
Is it there?
Now okay. Now
yeah,
okay.
Now
okay.
it is there. Now it is.
Yeah, sir. This is the last slide actually, sir. This is the last slide actually, sir. Yeah. So
okay, go ahead.
This is Bell's list. You can check the predatory journals, standalone, hijacked, all these. These are the journals. You can click the link and you can check. So if you have already published, remove it from your database, and awareness can be created institutional wise or personal wise among the researchers and beginners and students and the colleagues also. Thank you so much for your time, for your patience. I'll conclude here. Thank you. Thank you all.
Thanks a lot, and we are overly sorry. It's a nice presentation and an excellent with a lot of information. So now, finally, I would like to thank the Dean of College of Arts and Applied Science and the chairperson of the department for hosting the symposium. My sincere thanks to all of the speakers and the participants across the globe for being the part of this symposium. I would like to invite Dr. Saber to say a few words and also to open the way for the question and conclude the symposium. Dr. Saber, the mic with you.
Okay, thank you.
Go ahead, the mic with you, Dr. Saber. So you conclude and open the questions if is it possible. So the concluding on your
and you
side.
have concluded very well, Dr. Musallam. But I must say thanks to some special people who, what should I'm thankful to our speakers.
Dr. Sabir, open your camera, please.
My camera is open. You check.
Right?
My camera is open. You check.
His camera is open.
Okay. Where are you speaking?
You can't see me?
No.
Dr. Musallam, can you see me?
Yeah, I see you.
No, but Dr. Musallam is seeing me. So this is enough, because today was the hero of today's show was Dr. Musallam. from
Okay.
our department. He did his job very well.
So, Dr.
Thanks a lot, Dr. Saber. Thanks a lot.
Please, I took 2 3 minutes. I just wanted to fix in my mind to from where should I start? Should I start from the chair of the department who worked very hard with me to materialize this situation, to materialize this symposium? And then my thanks goes to the speakers. They spared their time and they stayed with us for long 3 hours. It is more than 3 hours. All the speakers are here, and definitely everyone is very busy. Dr. Khaliqur Zaman Sahab, he's teaching in one university, and he's a special guest lecture, faculty for more than 2 or 3 universities, I think. And Dr. Anjum is taking care as a principal of the Rizvi College, and Rizvi College is a very big and very old institution of Mumbai. Anyway, I, on my behalf, on behalf of my college, on behalf of my dean, on behalf of my chair, and on my personal behalf, I pay my sincere thanks to my all speakers, Professor M. A. Farooqi, Dr. Anjumara Ahmad, Dr. Khaliqur Zaman Khan, and all my colleagues and Dr. Shadda, and all my colleagues, department colleagues, and Dr. Zafar. They spared their valuable time and they shared very informative informations, whatever they shared with us. And definitely any program cannot be, any event cannot be successful without the participants. So definitely, I must say thank you very much for all participants. And among the participants, there are some people, very senior people are here with us. Dr. Adil Zadi, he was with us in the Dhofar University, and now I can see he was all through with the symposium. He joined in the beginning and still he's here. So thank you, Dr. Adil. And he passed my request to the university, and many people from his university has also joined. And there are many senior people here. Uh, I pay thanks to everyone. Dr. Vivek Singh is, I can see his name. Dr. Vivek Singh is here. And many people here. So, excuse me of not calling everyone, but I mean with everyone. So I pay my sincere thanks to everyone, and we will be meeting. We will be meeting soon, as our chair, Professor Asif, has promised me. We will have such type of programs again, and we will be again here on the same platform, inshallah. And thank you very much. And if Professor Asif would like to say anything, Professor Asif, would you like to say anything now?
I think you said already everything. So I am actually really very happy to have all with us. I think more than 3 hours. It's very difficult to sit even 3 hours, but I was very happy to see in Zoom meeting almost the maximum cap was 100. So almost in 3 hours the cap was almost 100 because maximum in Zoom we can enter 100. So 100 participants. So I was very happy to see this, and the rest other people, they were on YouTube. So overall, I'm really very happy and very excited also. Excellent presentation, excellent participation, and excellent speaker. So I hope, inshallah, in future, near future, we will have more symposium, and plus we are planning to have a conference even. I will work with my colleagues, and inshallah soon we will be coming with the symposium and with the conference also. So thanks a lot, everyone. And if you want to say, Dr. Sabir, anything, so that's all from my side. Thank you very much.
some people are still asking how we will get certificate. So their link is there.
Oh, still many, I saw many people, they already printed even certificate and
Vinat is asking.
Yeah, the link, actually I shared the link. You have to go with that link and just follow the link, fill the form, and the certificate will come in your email. So very simple, straightforward.
And Dr. Saab, 1 minute, Dr. Asif. There are many colleagues from our college. Department colleagues are there, but there are many senior colleagues from our college. Thank you, Dr. Biju. And thank you, colleagues from CCBA. CCBA, many people, faculties are here. Thank you, everyone. Thank you, everyone. And let us close it.
Okay, Dr. Saab, just 1 minute, last minute. Actually, all the time, actually, problem was continuously there was a lecture, but we could not give any time to our participant if they want to share their idea or anything for improvement in future. So actually, I want to hear from them, or even if they want to send their email, so I will be very happy to receive their email. And if they want to share any ideas, so now it's open, although it's all already over, but still if anyone wants to share his or her ideas, so I'll be very happy to hear that. So now floor is open for everyone.
If anybody wants to ask anything like this, because we didn't ask the question from the speakers.
Yes, dear sir.
Now, if anybody's asking anything, you are free.
Okay, Dr. Abdul Hamid, yes.
Yes, sir. We are very thankful to you for giving such a platform.
Oh,
but
welcome.
It will be great if there is some answer question session. And one more thing, we will be very much happy if international conference will be organized from your side. That will be nice. As you said, we are going to organize some conference. Well, that will be great. And we are thankful for such a platform. Thank you.
Welcome.
Thank you. Thank you, Ahmed sir.
Any other one want to share his or her idea or comment or suggestion? Dr. Adil, we want to hear you.
Dr. Adil is here. Dr. Adil here with his team. Many people have joined from Chennai. From St. John's College, also many people have joined. Dr. Asif, Dr. Sanjay Jain is.
I mean, can I ask, do you have a record for video for this symposium?
Yes.
Can we get the link, please, Doctor?
Yeah, link, if you will go on YouTube, for example, there is a YouTube channel we have. So just follow the YouTube channel and you will find video over there, and you can actually subscribe our channel and then later on whenever you want to see the video, so it will be available there.
Yes, same link.
Thanks. Thanks.
Welcome. So our all symposium, lectures, so everything is available there. Okay, I think there is no other comment, suggestion, so we will stop here. So thank you very much, and inshallah soon we will see you in coming symposium and conferences. Take care of yourself, and see you inshallah in next time in symposium or in conference. Have a good time. Assalamu alaikum.
Wa alaikum assalam. Thank you.